Push or
D?
pull? A force is a push or pull, right?
Push or a pull? Okay.
It's like
Yeah.
basically to
Say.
move object.
Good. Good. And Ruba, what is the force?
Push or pull upon an object when getting in contact,
Getting in
interaction
contact.
basically. Yeah,
That's a good
interaction.
point. Yeah. Getting in contact. Okay. We will discuss this point soon, right? Okay. So yeah, overall it was a good feedback. Everyone was correct. Okay. So let's start with the discussion with the types of force, right? We will discuss ki what is a force. So as everyone said, ki a force is a push or a pull, right? And yes, that is correct. So if I choose color, okay. Imagine you have a box. Okay, why is it not accepting my input? Okay, let me change the color. Okay, okay. My PowerPoint is angry with me. Let me just restart the slide. And September we have courses. Okay, I believe it would work now. Yeah, okay. So imagine you have a box over here and you have, let's say, a person standing over here. Let me call him Ali. Okay. Ali applies a force on it, F. So what would happen to this particular box? It would obviously move in this direction. Okay. Let's say Ali stopped applying a force at this particular point, right? And it stopped, right? So you can see Ali applied, he basically applied a push, right? And that caused what? The motion of the object to start from point A to point B, right? So you can define a force as a push or a pull. That's a standard definition. If you have it's in your exam theoretical question, like okay, what is a force? That is the enough definition to describe it. We had different types of forces, which we had discussed in the last chapter. So let's quickly skim what we discussed in the last chapters, right? We discussed gravitational force, right? And we discovered magnetic force and we discovered electrostatic force, right? Interesting factor about this is as follows, right? Rupa said, "Ke, sir, force is a quantity which requires two things to be in contact, right? But we have gravitational force, we have magnetic forces, we have electrostatic forces, which are basically applying forces on each other, but they do not require contact, right? Let me just describe and draw some scenarios for you. Let's talk about magnetic force, right? We will discuss this in the future chapters on magnetism. Okay, so let's talk about magnetic forces over here. So let's imagine you have two magnets. I believe you have played with the magnets in your childhood, right? Everyone has. Imagine you have two magnets, right? And this is north pole of this particular magnet and the south pole. And let's imagine I have the same poles aligned, right? So what happens if you have like poles coming toward each other? What is the direction of
Sorry, they repel.
they repel, right? So you're gonna have a force in this direction, right? You will experience this force on your hands, right? Because you're trying to bring them together, but they cannot be brought together. They are you experience of a force on your hand, right? But what do you see over here? There is no contact, right? There is no contact over here. Still, there are forces, right? So if you talk about forces which involve motion, which involve basically motion like this, a person pushing up, pulling a box, or a car moving across a road. So yeah, that need a contact, right? But we have forces which does not require any contact, like magnetic force, right? Let's talk about gravitational force, right? We will discuss this in detail, and we have discussed this in the last class also. Let's talk about this gravitational force, right? It is a pretty interesting factor, right? Just imagine a universe which has been born from billion of years, right? Still, it is moving with the precise motion, right? Imagine this is the sun over here, and imagine this is Mother Earth, right? This is the Earth after Mars. Okay? Sorry, you have Mercury, Venus, Earth. This is Mother Earth over here, and it has been moving in this particular orbit since billion of years ago, right? So from billion of years, it has maintained this particular orbit, right? So what is the factor which is causing it to stay like this, right? That is gravitational force, right? So if you have two bodies, this is trying to basically apply a force. The Earth is trying to basically apply a force on Sun. That is called Fg. Okay. And similarly, the Sun is trying to pull the Earth, right? Fs. So this couple of forces exist without any contact, right? So you have also these type of forces which does not require any contact, right? So this forces is maintaining the particular orbit over here. If the Earth changes this orbit slightly to the, let's say if the orbit radius increases slightly over here, or if the Earth comes over here, right? This can lead to extreme fluctuations, right? In temperatures. Let's say if the Earth comes closer to the Sun, okay, let's say this is the position E bar, the temperature would reach hundreds of Celsius, right? And the life would not survive, right? Imagine if the Earth goes over here, okay? Let's say if there is a meteorite which hit the Earth and it came over here, right? So this can make the temperature to go below 0 Celsius, right? And still the life would not survive, right? Just imagine the beauty of the God, right? And scientists, right? Scientists like Einstein, who do not used to believe in God. Scientists like Stephen Hawking, who was also an atheist, right? They started believing in God when they were basically at the end of their lives, right? Because when they discovered these principles, perfection of the universe, right? They just gave up, right? They did not accept any particular religion. They just believe that there is someone, right? There is someone who's controlling the entire universe and is maintaining the entire beautiful, you can say, balance of everything, right? Nothing is basically extreme, right? Earth is at a perfect position so that the life can be supported. Okay. And then we have electrostatic forces, right? So electrostatic forces would be done in chapter number 4, that is electricity. So let me just give you an example of electrostatic forces, which again does not require any contact, right? So this concept needs to be built over here. So forces can be between two objects which are in contact, and force can also be between two objects which are not in contact, like gravitational force, like magnetic force, right? And like electrostatic force. I'm gonna test your chemistry concept, right? Now. I want Maeve to answer first, then Ruba. Okay. Imagine you have a positive charge and you have a positive charge, right? And I'm trying to bring them together, right? Where would be the direction of force? Maeve,
Yeah.
can you speak
It
loudly?
is like it will move apart, right?
Would it repel or attract?
Like it will repel.
It would repel, right? Ruba, do you agree with Maeve?
Yeah.
Yes.
Right. So like charges repel. Similarly, they are not in contact with each other, and still you will observe this particular motion of the protons, right? They are repelling each other. They are moving away from each other, right? So this will be done in the future coming chapters, that is section 4.2. And we'll discuss this in detail. How does this force is created, right? There are some electrostatic field lines, which we will see in detail. And how does this produce this particular effect, right? Okay, so as Ruba said, certain contact forces occur between objects that are touching each other. Yes, they can generate forces. Okay, so we have drag, right? We have air resistance, right? Imagine, let me draw my Bugatti. Imagine you have a Bugatti, right? And you're driving across the road, right? And obviously, when you're pushing, let's say you're moving forward in this direction, there would be opposing force, right? That will be air resistance, right? Whenever you have air, you will have air resistance. Imagine you're swimming, right? Imagine you're swimming underwater, right? Let's say this is Hamza. Hamza swimming over here. Okay, as Hamza is trying to swim over in this direction, there would be a force which will try to stop Hamza, right? There will be force of drag, right? So these forces basically leads to resistance in motion, right? So these are called resistive forces over. Okay. So anything, let's say, which is going through a fluid, right? Let's imagine if let's say a person is running, right? Let's say he's running in this direction. He would also face a small air resistance, right? You might have seen, let's say, if you're running or jogging or running, if you're running at a higher pace, right? You would observe there is some air trying to slow you down, right? So these are all called what? They're called resistive forces. They try to resist your motion, right? So types of forces, you should be clear which are resistive forces, what are contact forces, right? And what is a thrust? Can anyone tell me what is a thrust? Raise your hand and answer. You have your answer on your screen right now in one of the diagrams. What is the thrust? What is thrust? Give me a guess. Yes, Varda.
सर एक ही डायरेक्शन में ज्यादा फोर्स लगाना है.
Okay, good. Anyone else want to guess? Quickly, I want quick responses. Can be wrong, can be correct. No worries.
Sir, sudden force in a particular direction.
Sudden force in a particular direction. Okay. So thrust is just the push of an object, right? Okay. This car is basically having a forward force of F, right? Which is provided by the engine, right? The engine ने push किया है इसको to basically move with force F. Similarly, when you're moving with force F, that is the force provided by your body, right? So this is the thrust or driving force, which is causing the object to move in the particular direction, right? ठीक है. So how can we represent force? We can represent force using a free body diagram, right? So we know okay, let's say if we are drawing a very good diagram, you can see my skills. Yeah, let's say imagine if you are a student of Picasso, you can draw such exquisite diagrams, right? Let's say if you're not a good let's say artist, so you can just represent using a free body diagram, right? What is a free body diagram? You just use a block, right? Let's imagine this is the car, right? And it has two forces, right? One force is basically causing it to accelerate in this direction, and one force is trying to stop it down in this direction, right? That is air resistance. So this is basically a simple representation of any body, right? Resistive force, air resistance, right? So does that make sense? Let me just give you an example of free body diagram. Free body diagram. Let's imagine this. You have this box over here, box here, right? And this person, let's say this person is trying to pull this, right? Trying to pull this box in this direction, right? So the force applied to the box is in this direction, and there will be some friction, right? In this direction, right? A friction. So I can just represent this using this particular block diagram, right? That it will be as follows. You have a box A, and you have one force in this direction, and you have another force in this direction, right? F friction. That's it. So you just think about any object as a block, okay, and you just represent the forces as vectors, right? So how do you represent the force? How do you represent a force is as follows. You represent a force as a basically vector, right? This is a vector. This thing is called the head. This thing is called the head. And this thing is called the tail, right? This is called the head of the vector, right? And why do we use a vector arrow to represent the force? Since this force is a vector quantity, right? Why is it a vector quantity, Ruba? Why is force a vector quantity?
Because it has a direction.
Yeah, it has a magnitude, it has a unit, and it has a direction, right? Right? This is basically why we use arrows to represent forces, because it will have a particular direction. It has, let's say, if I just say this force is 5 Newton, right? So this is the magnitude. This is the basically the unit of the force, and this is the direction of the force, right? That is why it is a vector only. Okay. I have some comments over here. Yeah, I will discuss this about the book after that class, right? So no worries. Okay. So is this clear? If any section is unclear till here, so let me know. Otherwise, give me a thumbs up. If all content covered till here is clear, give me a thumbs up quickly. Rubako, it's clear. It's clear to Hamza, it's clear to Varda. Azan is here, okay. It's
Assalamualaikum,
clear to
sir.
Ruba. Azan, try to make sense where what we are covering. You can watch the rest over the recording, right?
Okay.
Is pushing someone also comes in thrust? Yeah. So we are providing a push for the object to move in that direction. Yes, Mashal. Maybe is it clear?
Yes, sir.
Okay. Quickly use some Zoom tools. Okay, ताकि I can just quickly get your feedback. Okay. Okay, so now since we know all the types of forces, right? We know what are forces. Force is a push or a pull. We had discussed the types of forces. We have magnetic force, we have electrostatic force, we have gravitation force, right? And then we have contact force. We discussed about the resistive forces, which tries to oppose the motion, right? That is air resistance and basically drag of water. Thrust is basically the push which is driving some object, right? Either your body or your car. Okay. And how do we represent force? We represent force using a vector that is as follows, right? And how do we draw the free body diagram is as follows, right? I hope it is clear. We will do some examples in the next slide so it will make more sense. Now we are going to start an interesting topic, right? That is called extension, right? So imagine this. Imagine this before getting into content of this particular slide. Imagine you have, let's say, a support and you have a spring, right? It's empty right now. This is the original length of the spring, L. Now, what do? You add a weight over here, right? So what happens? You add a weight and this spring becomes what? It stretches, right? Let's say this is a block A. So actually, this was the original length of the spring, right? Now it is basically as follows, right? So the spring has extended by an extension that is E, right? So if I applied a force that was of the weight which I attached with the spring, the spring was extended by an extension that is called E. Okay. So basically 300 years ago, right? Approximately 3 centuries ago, this experiment was done by Robert Hooke, right? An experiment, an experiment by Robert Hooke. Does anyone know who was Robert Hooke? Has anyone watched a video or watched this documentary वगैरह or this experiment
Sir,
we do? Yeah.
I learned in school about Hooke's law.
Does anyone know about Robert Hooke? You know, I'm gonna tell you about Hooke's law. Does anyone know who was Robert Hooke? Okay, so he was an experimental physicist, right? So we have two types of physicists, right? So we have physicist over here. It has two types. One are theoretical. One type is theoretical, and the other type is experimentalist, right? Experimental, right? So इस कैटेगरी में आता है आइंस्टाइन, स्टीफन हॉकिंग, ठीक है। इस कैटेगरी में आते हैं रॉबर्ट हॉक, टेस्ला, ठीक है। सो आइंस्टाइन की basically just gave theories, right, which are getting proved right now. He gave a theory of relativity which is getting proved by this particular era because हमारे पास टेक्नोलॉजी अब एडवांस हो चुकी है. We have the advanced technology right now. Experimentalist was basically Galileo Galilei also, right? ठीक है. Can anyone tell me what did Galileo Galilei did in his lifetime? What did he discover? Yes, Maeve. Do you remember any experiment which Galileo Galilei did, and you have covered that in your content, or you have watched some scientific documentaries, so on and so forth?
No, not yet.
I cannot hear you, Maeve.
No, no, I don't know anything.
Still not audible.
I'm not sure about it.
Not sure. And we
Yeah.
have the new entrance over here, that is Azan. Azan, do you know who was Galileo Galilei? An experiment, famous experiment by him.
No, sir.
No, sir. Okay, we have no interest in physics over here, right? So he discovered, you can, if you recall, the Lean Tower of Pisa experiment, right? Just search about it after the class, right? Lean Tower of Pisa. And he also proved that Earth was not the center of universe, solar system. ठीक है. Let me just quickly tell you the story of Galileo Galilei. So before there was any telescope, before there was any technology, people used to think कि हमारा Earth is the center, right? And the sun used to rotate around the Earth, right? Sun and the moon, right? This was called heliocentrism, right? This was called heliocentrism. So we used to think that Earth is the center, and the sun and the moon and all the other planets used to rotate around the Earth, right? But what did Galileo Galilei did? He broke the entire basically convention, right? The beliefs of people. He invented telescope, right? He watched the stars, he watched the sun, he watched the moon with a telescope, right? So he experimented using a telescope, and he said that it is not heliocentrism. Sorry, let me just put the cross here. It is not heliocentrism. The solar system is basically geocentric, right? So what is geocentric, which we know till now, that sun is in the center and all the other planets is at the basically rotating around the sun, right? We have Mercury over here, and then we have Earth. Let me just draw Earth over here, and so on, right? So he got basically a lifetime jail for this. Just imagine if you go to a group and you say, okay, let's say the Earth is going to die tomorrow. Okay, they will just grab you off and throw you into the water, right? So yeah, we don't want to change our views, right? That's what happened to Galileo. But we discovered when the technology advanced, we saw okay, he was true, and people gave life for the love of physics, right? Okay, now we are on Robert Hooke. So Robert Hooke was also an experimentalist. He basically did what? He changed the weights, right? He changed the weights and he observed what is the effect of changing force on extension, right? He observed the effect experimentally. What happens if we change the F on the extension, right? So he want to relate these two things, right? So what he investigated is as follows. That was done 350 years ago. He found out that the extension was proportional to the stretching force. Okay. Why did that the spring was not permanently stretched over here? So if I want to write this down using an equation, that is going to be as follows. That extension is proportional to force, right? It is saying if you increase the force, your extension is going to increase, right? So if I plot this graph, if you remember your basic high school mathematics class, if you want to draw direct proportional graphs, how do they look like? We have extension over here in centimeters. Let's say, let me just do meters. Your extension over here in meters, and you have force over here in Newton, right? If you have a direct proportional quantity, how would you sketch this graph? Would it be a straight line passing through origin, or would it be something else?
Straight line passing through origin.
Yeah, it will have a straight line passing through origin. And how do you read this graph? If you increase the extension, the force also increase. Or if you just like to see it like this, if you increase the force applied, the extension also increases. Okay, if you decrease the force, likewise the extension also decreases, right? That is called the direct proportional relation, right? But we have interesting point over here. That is limit of proportionality, right? Now imagine if I just keep on repeating this experiment and I just do this. Okay, I put a very huge mass now. Okay, I put a very huge mass. Let's say m, right? Now if I remove this particular mass, let's say this was the original length of the spring, right? Your L is your original length of the spring, original length, which was defined here, right? This was the original length, which you can see. Now if I remove this load, if I remove the mass, what happens? I see the spring is basically still like this, right? It is not going back to its original length, which was this, right? Which was this. So it means your spring is now destroyed. It has crossed the limit of proportionality, right? So what is the limit of proportionality is as follows, right? It is the point at which the load extension graph becomes non-linear, right? So after this particular point, there would be a certain point, let me call it A. After this graph, after this point, this would be like this. Okay, यहाँ तक it was linear. What does linear means? Linear means it's a straight line. Okay, this is a linear graph. And what does non-linear means? It basically is a curve, right? Or like this. ठीक है, this is a non-linear graph. This is a non-linear graph. Okay, I hope it makes sense. If it makes sense,
Yes,
if it is
sir.
clear till now, give me a thumbs up quickly. Okay, it makes sense to Varda. Just use the tools of Zoom quickly, ताकि I can get a feedback from you guys. Okay, it's clear to Mashal, Ryan, Ruba, Maeve, and to Azan also. Good. Okay, so we have this particular graph, right, which we have seen in the last slide. Okay, so we have some certain points over here which you need to analyze, right? So you have extension over here on the x-axis, right? This is called an x-axis if you want to relate with your mathematics class. This is called a y-axis. Okay, so on x-axis we have the extension that is in millimeters usually, and on the y-axis you have forces and force in Newton, right? You can see from point O till point E, right? The graph is a straight line. So this point is called the limit of proportionality. The limit of proportionality, that is saying that the statement which Robert Hooke made is as follows, right? Force is highly proportional to extension, right? So this is going to be followed under till this particular range, right? And if it crosses the limit of proportionality, this this law is not followed, and you can see it becomes, you can see what it becomes non-linear, right? Okay. And what happens to a spring after this? It basically is not able to, spring is not able to regain its original shape, right? You might have played with a spring. Imagine just take a spring and extend it with a huge force, right? And try to leave the spring. It would not gain its original shape, right? And just try to extend the spring slowly, okay, till you reach the particular point. You will observe it experimentally also, right? The spring is not able to regain its original, the original length, right? Okay. I hope the graph makes sense. And you can see after this particular point A it crosses, it will not be able to regain its original shape, and this law will not be followed, right? So till this range, you have what? You have this condition true, that is f is proportional to the extension. Over here, you don't have this. Okay, it is not proportional to extension, right? It is not proportional to. Okay. So spring constant, right? Up, let's analyze the equation, right? What we have obtained till now, we have the following equation, which says k. Let me see the slides. Okay, I want Azan and Maeve to stay after the class for 10 minutes. I want to discuss about the content in the book, right? Okay. So we have 1 minute left in the meeting. I want you guys to rejoin with the same link as soon as possible, right? I'm ending the meeting right now. Everyone rejoin.
Yes, sir.
Okay. So I believe everyone is here. So let's start the discussion. So what do we have? Let me just sketch the graph again. So we have this particular graph, right, which we have seen. We have the extension over here in millimeters. And then we have the force over here in newtons. Imagine we have this particular graph and I'm not crossing the E point, which you see over here, right? I'm not crossing the limit of proportionality. I'm staying under it. So it's going to be a straight line here, right? This is point O. So what is the slope, right? We have this relation, right? We have this relation that f is proportional to extension. So if you recall your mathematics class, and if you want to remove a sign of proportionality, to introduce a constant over here, right? So that constant is basically called K E, right? So your this formula is called the Hooke's law, right? Hooke's law. And if you try to make K subject, you get us follow that K is F upon E, right? And this quantity is called the spring constant, right? This quantity is called the spring constant. Okay. So can anyone tell me, seeing this formula and this particular graph, how can we obtain, let's say if you have this particular graph, how can we find the value of K experimentally? Yes. Anyone? Give me a guess. A good one or a bad one. Yes. A guess. A quick guess. जल्दी से बताएं. Let me call the name. You want me to call the name? Okay. Yes. Azan. How do we get, if we just see this expression and let's imagine you have this particular graph in your end, how would you, let's say, find k from this graph? Azan, you're not audible.
I don't know. Yes, sir.
Azan, can you speak loudly?
Can you hear me?
It's not audible.
Hello.
Okay, fix your mic. Anyone else? Yes, Ayan. Ayan, how do you get k? Okay, ठीक है. किसी को नहीं आ रहा. No worries. Let me insert a slide, a blank slide. Let me recall your basic mathematics concept. Let's say if you have x over here, if you have y over here, if you have a straight line, right? You have a point A over here, you have a point B, right? Your point A is basically x1, y1, and your point B is as follows, which is x2, right? Right? And how do we find the slope of this? This is changing
y2
by,
minus y1
yes,
upon x2 minus x.
right. Okay. So we basically follow this formula which Hamza said right now. This is x1 comma y1. This is x2 comma y2. So if I want to find the slope, what is the slope, by the way? It is basically stating k, that is basically change in y over change in x, right? So the quantity which is basically on y-axis, the change in that upon the quantity in x-axis, I want the change in that, right? That is equivalent to y2 minus y1 upon x2 minus x1, right? Similarly, see this over here. Imagine I gave you 2 points, point A, point B, right? And if you find the change over here, right? You want to find the slope. So how would you find the slope over here? That would be change in force upon change in extension, right? This is change in force, that is change in y, and this is change in extension, that is change in x, right? That is equivalent to force upon E, right? You compare the formula, it's same, right? So the slope of this force extension graph is going to give you the value of spring constant K. Does that
सर
make
ये
sense?
f इज इक्वल टू के ई में k क्या है?
Yes.
इज इक्वल टू के ई में k क्या है?
What is this? K is a spring constant, right? Make sense?
Yeah.
Okay. So is this clear? How do we get K experimentally from the graph? If it is clear, give me a thumbs up so that I can move on. You have a question ahead and which you want to solve. So make sure it is clear.
So could you
Maeve,
explain
we
it
have a
again?
question.
Yeah, could you just explain it again?
It's not audible.
Could you just explain it again?
Should I repeat that?
Yeah.
Okay, ठीक है. Okay, sure. So is this clear? Is this clear?
Yeah.
Okay, ठीक
Yeah,
है. Now
that's
similarly, find this, see this thing over here. ठीक है. What do we have over here is as follows, right? We have, this is, let's imagine if I just plot the points over here. This is E1, right? This is F, right? Similarly, if I plot this particular point, this is E2, this is F2, right? So this will be the change in F, right? Delta F. So this change, this is basically delta F, right? Which was previously delta y, right? It is equivalent to delta y, change in y, because on y-axis I'm plotting forces. Similarly, this change is called as delta E, that was basically before delta x, because on x-axis I have now extension over here. So if you find the slope of this, that would be basically the force upon extension, right? And if you have seen this from, if you derive this formula of the slope, now if you try to see the formula actually from the Hooke's law, right, that says your spring constant is equal into force upon extension, right? This formula matches, right? So therefore, the slope of force against extension graph will give you the value of spring constant, right? And if you recall your mathematics class, if you take any other points on a straight line, your slope will be constant, right? So if you find a slope using point AC will be equal to, if you find a slope using point AB, if you use let's say point BC to find the slope, you will have the same constant answer because it's a straight line, right? It's a straight line. Similarly, you can use any 2 points on a straight line over here to estimate the value of spring constant. Make sense?
Yeah.
Okay, good. Make clear? If it is clear, give me a thumbs up. Your voice is way too low. I have to just zoom into my speakers with my ears to hear you guys. Okay, good. Azan, it is clear or not? Is it
Yes,
clear?
it is.
Okay, good. ठीक है. Yes. Who is that? Who was that? If you have a question, please.
सर गलती से
Okay, no worries, no worries. Okay, so now if it is clear, and I believe here you have get the idea of the Hooke's law, I want you guys to take out a pencil and a copy and a calculator to start solving this question, right? So you're given what? First of all, whenever you solve a question, you basically write down the data, right? Let me sketch the diagram for you. You have basically the spring over here, which is stretched by a weight of 2 newtons, that is W. It has a weight of 2 newtons. Let's say this was the original length, L. The extension in the spring is basically E, right? And you're given the value of the extension, sorry, that is E. You're given extension and you're given the weight, right? So extension is given to you as 0.01 meters. Make sure your length is in meters and your force is also given as 2 newtons. So in first part, you want to estimate the value of K. You know, okay, this is the Hooke's law from, right? So now, Jalli, I'm going to give you 2 minutes to solve. I want the answer from everyone of part A and B, then we'll do it together. Okay. So make sure whenever you're in a class, you have a copy in your hand, you have a pencil and you have a calculator. Okay.
सर इसका यूनिट क्या होता है के का?
I can call anyone, okay, to ask for the answer.
सर इसका यूनिट क्या होता है?
Yes, Hamza.
पार्ट ए में के का क्या होगा?
Finalize the part A and B, then I will tell you the answer, right?
Sir, he is asking the unit for K, spring constant.
That I want you to guys to figure out. We discuss in a while. कैसा होता है, क्या होता है.
Okay.
I believe you're done. So let's continue. You can match your answer with me. Okay. And that's a good question, right? What would be the unit of K, right? What is the SI unit for this? That's a good question, Hamza. And if you guys have figured it out, that would be great. So let's start with the part A and let's see how we solve about it, right? So the part A can you're given the extension that is 0.01 meters. You're given the force also that is 2 newtons. First of all, let's derive the SI unit of K. You have this following formula that F equals to KE. Let's make K subject, that is going to be F upon E, right? And force is measured in newtons, right? Extension is measured in meters. Therefore, the SI unit for K will be Newton per meter, right? Okay, so now let's solve this question. You want to make K subject, you know the force, that is 2. You know what is the extension, that is 0.01. It's 1 upon 100. So your K is coming out to be 200 Newton per meter. If your answer matches with this particular value, give me a thumbs up. Okay, it matches for Ruba, Varda, Mashal, Rayan, Hamza, Maeve and Azan. Are you solving the question? Okay, Azan का match हो गया. What about Maeve?
Yeah.
Is it the same as your answer or your answer is varying? Maeve, give me a thumbs up if it is same. Your voice is pretty low. I will need to use some headphones in the next class, right? Okay, ठीक है. Okay, so part A is done, right? So what is part B? So you want to find the weight at which the spring will have an extension of 0.08 meters, right? Okay. So let me insert a blank slide over here. And I have a good question for you guys. Now they're saying, okay, if we have an extension of 0.08 meters, what would be the force of the weight that will cause the extension, right? So we have this following relation that F is equals to KE, right? I know the extension. Do I know the K over here? Do I know the K?
Yes.
Yes.
Yeah, so which we have figured it out in the last part. And spring
Yes, sir.
spring constant for a particular spring remains same, right? So a K is constant, which you have got from your first part, that is 200 Newton per meter. So you can use that over here. You know, K is 200 Newton per meter, right? So therefore, just put in the value. It is going to be 200 times the extension, that is 0.08, and your F is coming about what? 200
16 Newton.
16.
it's
16.
16 newtons, right? And if your answer matches with this, give me a thumbs up. It matches for Mashal, it matches for Azan, Rayan, Hamza. Okay. Matches for Ruba also. What about Maeve? Yes or no? I believe she got the answer. Okay, yeah, she got the answer. Okay. Good. So forces and resultants, we're gonna just cover this till here, gonna end the class because I have another class in 3 minutes. So yeah. So let's see what is being shown over here, right? We have discussed this in the last slide. It's just a summary of that. They are simply stating over here, which we have seen, force has a magnitude and a direction, right? That is why it is a vector quantity, which we have seen in the last slide, right? So it is represented by in the free body diagrams by a straight line with an arrow to show its direction of action, which we have seen. Okay, we show a force by this, right? It has a direction. It has basically in this, it has a magnitude. Let me just fix my spelling. It has a magnitude plus a unit in this value. Okay, and this is the direction. That is why it is shown by a vector, right? And it is a vector quantity, right? So this is an interesting statement over here. Usually more than one forces acts on an object, right? Imagine you're sitting on a chair or a sofa or a bed, okay, and anywhere you're sitting, right? So imagine a ball on a table over here. It is basically not moving, it is stationary, right? So you assume that this is the center of this particular object, right? For simplicity, we basically assume okay, we take the center of mass, right? We have discussed in the last chapter what is center of mass, right? So what is center of mass, Hamza? What is center of mass? Is Hamza here? Yes. Hamza, what is center of mass? So anyone else who wants to participate and explain center of mass? I want you guys to answer this question. So it's basically the point at which all of the mass is basically appearing to act, right? It is a point at which all of the mass is concentrated, right? all of the mass of an object is concentrated, right? So we assume for simplicity in physics, okay, this is the point where we can just show, okay, this is the object center of mass, where the entire mass is acting of an object, right? So एक तो vector is the weight, which makes sense because of gravity. And due to contact, we have another force that is basically acting upwards, that is called R, right? So if you want to find the resultant force, that is going to be a vector sum, right? Let's take this as positive, right? This direction is positive. So it's going to be W minus R. Since they both are same, so resultant force is 0, right? And that is why it is stationary, right? This bowl of fruit is stationary over here. It's not moving anywhere else, right? We will discuss okay, what does resultant force 0 means over here with this example, right? Imagine you have blocks, block A, block B, block C, block. Let me just give it a single name. This is block A and this is block B, right? So we have two cases over here. We have F1 in this direction and we have we have F2 in this direction, right? So imagine if you just recall your basic mathematics classes, and if you recall, okay, this was positive X, this is positive Y, this is negative X, this is negative Y, right? We're going to only concentrate on X axis right now, okay? So we can remove Y axis till now. So we have this, let's say this is the center point O. On the right, we have positive direction. On the left, we have negative direction, right? I'm going to take this direction as positive, right? So if I want to find the resultant force in this case, that is going to be what? The positive force F1 and basically negative minus the negative force. So, sorry. So you can see that F1 is also in this positive direction and F2 is also in the positive direction, right? So you just vector add them, right? It's simply addition of forces, right? So अगर दोनों same direction में है, you're gonna simply add them together. So it's going to be 1 plus 2. Therefore, the resultant force, the final force which is going to basically be pulling or pushing the object is going to be 3 newtons in this direction, right? Similarly, let's see the scenario B. You have what? You have this basically is a positive direction and this is basically in negative direction, right? So you can just simply add them up, like basically basic arithmetic, right? So it's going to be positive 3 plus negative 2, right? And this is going to be 3 minus 2. And the resultant force acting on this block is 1 Newton, right? In this direction. Why is in this direction? Because you got the answer to be overall positive, and positive states K, your motion it will be in this direction, right? This direction. So is this vector addition of forces clear? If it is clear, quickly give me a thumbs up. I'm going to give you a question right now to solve.
So could you
Okay, clear.
explain it again?
Yes,
Can
Mir.
you please?
Yes, Azam. Clear?
Could you explain it again?
Yes.
Okay.
Can you please
Yes,
explain
Mir.
again?
You had a question?
Yeah, could you explain it again? I didn't get this.
Which part? Block A, block B?
Yeah. Block A part.
Block B, block A.
A.
A,
Yes.
okay, we can. Let me just make it on another slide. You have a block over here, right? And you have one force in this direction, right? That is 2 newtons. You have one force in this direction, right? 1 newton. Imagine this is force 1. Imagine this is force 2, right? So as I said, if you, this is the center point of your x-axis, so this is positive x direction, right? And this is negative x direction. So if any motion is in this direction, we consider them as a positive value, right? So you can see if you want to find a resultant force, that is simply a vector addition. It's basically simply mathematical addition, right? So your F1 is in this direction, that is positive, so you will have plus F1. Similarly, if you see this F2, it's also in this direction, that is also positive. It's going to be plus F2, right? Just now put in the values to get your overall resultant force. The body resultant force, that is the final cumulative force that is actually causing a motion of block A in either left direction or right direction, right? So we have 2 plus 1. get positive 3 Newton, right? So the final scenario will be as follows, that this block will be moving to the right with a force of 3 newtons. Why to the right? Because this sign is positive. It states that motion will be in this direction and the magnitude of the force would be basically 3 newtons, right? Does that make sense?
Yeah, got it.
Okay. Now let me give you a question
Yes.
just to basically finalize this concept, and then we're gonna call off the class, or I'm getting text from the students. Is the class starting already? Okay. Let me just text them. Okay. So yeah. So okay. Test yourself. So you have this block A, and these are the forces acting on the block. F1, F2. Given F1 equals to 1 Newton, F2 equals to 4 Newton, F3 equals to 0.5 Newton, and F4 equals to 1 Newton. What is the resultant force acting on block? It's of 2 marks. Okay, quickly speed up. So you have this particular scenario and just want to find the resultant force, right? And how do you find the resultant force? As follows. Just resultant force is just basically vector addition, right? You see first of all F1, right? And this direction is positive, right? This direction is negative. So you see F1 is in the direction of positive, so it's positive F1, right? And F2 is the direction which is basically this. So therefore we'll put a negative sign with F2. Similarly, F3 is also positive and F4 is also positive, right? Because they are both in the positive direction. Now you can just simply, therefore, put in the values of the forces and get your answer. F1 was 4.51, right? So it's plus 1, negative 4, a negative 4 plus 0.5 plus 1, right? And what does it give you? 2 minus 4 negative 2, it's give you basically negative 1.5, right? What does a negative sign represents? That your final block motion will be as follows. It will basically be moving towards the left with a resultant force of 1.5 newtons. If your answer is matching, give me a thumbs up. Okay, it matches for Ryan, matches for Hamza, Mashal, Varda. Okay.
सर
Yes,
सर हम लोग उसको ऐसे लिख
Hamza,
सकते हैं 1.5 न्यूटन टुवर्ड्स द वेस्ट
can you speak loudly?
हम लोग ऐसे लिख सकते हैं 1.5 न्यूटन टुवर्ड्स वेस्ट
Not audible. Yes, बोला बस.
हम इसको ऐसे लिख सकते हैं कि 1.5 न्यूटन टुवर्ड्स वेस्ट
Yeah, towards north, south, east, west. Yeah, towards west. Yeah. Hamza is saying कि if you recall your map, this is north, this is south, this is east, this is west. So yeah, you can also write it down. K. This is as follows. K resultant force is 1.5 newtons towards west. So now this is the new content which we are going to start in this particular week. That are the Newton laws, right? So Newton laws. Anyone? What is the Newton's first law? Anyone who wants to answer, raise your hand. What is Newton's first law? What is Newton's first law of motion? Anyone? Give me a guess. Raise your hand and answer.
Sir, if an object is at rest, it will remain at rest, and if an object is in motion, it will remain in motion unless an external force acts on it.
Okay, that's good. That's good. That is very good. ठीक है. हाँ. So let me just give you a historical background कि हो क्या रहा था. ठीक है. So we had this particular thing over here. Imagine this is your grass. ठीक है. And this was Isaac Newton's time, right? and he was sitting under a tree. I believe you all have heard this story. I don't know it's a myth or something else, but is what it is a point after which these laws came into place, right? So basically, an apple, right, fell in front of him, right? So this was Isaac Newton, right? Okay, and apple fell in front of him. So what would you guys do? Let's say you are sitting under a, let's say, bright day under the tree, and you're thinking about the life,
So
right?
I would eat the apple.
Yeah, you would simply eat the apple. It's a red golden apple, right? It's a treat for you guys. You would just eat it out, right? So Newton bhai thought something. He had a thought process over here. Okay, why did the apple came down, right? So instead of a common human being as us, me and Ryan and every one of you, right, you would simply take the apple and enjoy your treat, right? But he thought, कि why? Okay, so physics का question, physicist, right? Every physicist, every physicist, ठीक है, जो भी theory discover हुई है, that was based on why, right? So every question, every theory started with why, and then they explored methods which explained, कि why is it happening as the way it is, right? So after this, he discovered gravity. ठीक है, he discovered that there is gravity, and as soon as he discovered gravity, he placed his three laws, right? That we are going to study today, right? So the first law is as follows, right? So what is it saying? The first sentence, right? Let's go step by step. It will make sense. Let's imagine you're driving in a car, right? This is point A and this is point B, right? Let's say you're driving at speed u meter per second, and at point A, you basically made the speed to be zero. आपने accelerator पे आपने जो आपका foot था वो आपने remove कर दिया. You remove your foot across from the accelerator, right? So obviously at a certain point it would come to a halt. It would stop. So let's say it stopped over here, right? So the first sentence is saying कि on Earth, right, where you have friction and air resistance, if you basically leave your accelerator, the car would come to a rest after some time, right? Right? Or you switch off the engine. It makes sense, right? So यहाँ पे it came out to be 0 meter per second, right? Okay. So अगर imagine this, imagine कि if there was no friction, if there was no friction, so what would happen, Ryan? If there was no stopping force, what would happen?
Sir, uh, the object or car would go in constant motion.
Good. Imagine this is Earth over here, ठीक है? You are over here, right? And you throw a stone in space, right? In this direction. So it should ideally continue to move, right? Because there is vacuum in space, right? And vacuum means that there is no air. If there is no air, that means it has no air resistance, right? So he thought about this thing. Okay, in space there should be this phenomena over here. Okay, this object that is A, it should keep on moving till infinity, right? Similarly, this is the case over here. Imagine there was no friction in the car. There was no friction available on Earth, right? So the car would keep on moving in a straight line, okay, in a single motion, okay, with constant speed, right? So that is so. And then he basically went on. He said that force is not needed to keep a body moving with uniform velocity, while there no force is basically opposing force are acting on it. Okay, so he's saying that if you imagine this scenario, let's say he threw the stone at speed of 10 meters a second. So this was basically keep on moving in this direction for infinity, right? At a constant speed of 10 meter per second. If there is no friction, right? Yes, Ryan, you had a question?
No, sir.
Okay. So now imagine this. Say, so this idea was proposed by Galileo, and this was basically summed up in Newton's first law of motion, right? So what does it say? As Ruba said, के sir definition Ruba ने बताई, that was exactly correct. Okay, what is Newton's first law of motion? An object either remains at rest or continues to move within a straight line at constant speed unless it is acted upon by a resulting force. Right? So what does it say? What is Newton's first law? Newton's first law. Acha, it is also called law of inertia. Okay? Law of inertia. So it says the following things. Okay? An object at rest remains at rest. Okay? Imagine your car is stopped, so it will basically be at speed zero until unless you apply engine force to basically start it to move, right? Remains at rest. Okay? An object, an object in uniform motion continues to move at constant speed. Now, this is the interesting point. Until a resultant force acts on it to change its state. Okay? So this point is pretty important over here. This particular point is pretty important, right? So ये कह रहा है कि अगर ऑब्जेक्ट रेस्ट पर है, so object will remain at rest, right? That makes sense. An object at continuous motion will remain to move in continuous speed until and unless it basically a resultant force acts on it to change its state. Imagine कि यहाँ पे मून है, ठीक है? लेट्स से वो मून को हिट कर रहा है एंड देन ऑब्वियसली मून विल प्रोवाइड अपोजिंग फोर्स एंड ये ऑब्जेक्ट ए विल बेसिकली बिकेम स्टेशनरी एट हियर, राइट? सो उस पे रिजल्टेंट फोर्स एक्ट हुई तो वो रुका, वरना इट विल कीप ऑन मूविंग, राइट? दैट इज द समरी, दैट इज द क्रक्स ऑफ न्यूटन्स फर्स्ट लॉ, right? I hope it makes sense. If it makes sense, give me a thumbs up. This is pretty important, right? Does that make sense? It makes sense to Ruba, not Ruba, Rayan. Sorry, it makes sense to Ruba, Rayan, Mashal, Azan, Maeve. What about Varda? Yeah, it makes sense to Varda. Yes, Varda, question?
No, sir, I don't have a question.
Okay, okay, good. दिस इज द फाउंडिंग प्रिंसिपल जो न्यूटन ने सोचा है, राइट? कि अगर मैं लेट से एप्पल को फेंक दूं, एप्पल को थ्रो कर दूं इन स्पेस, लेट से इफ आई थ्रो द एप्पल, लेट्स इमेजिन दिस इज एन एप्पल, राइट? इफ आई थ्रो दिस एप्पल इन स्पेस, what would happen to this apple, right? So he discovered these two principles, right? And it works perfectly fine, and that is why studying in your syllabus, right? अभी तक ये valid है. It has not been proven wrong till now. ठीक है? So, okay. So, how do we link mass and inertia? I said कि first law is also called law of inertia, right? So, can anyone tell me how can I link mass and inertia? ये हम पहले पढ़ चुके हैं in the first chapter. How can I link mass and inertia? Anyone? It's a pretty interesting relation.
Mass resist change and inertia also.
Anyone, give me a guess. It doesn't need to be correct or wrong. I just want to see what are your concepts till now.
सर आवाज आ रही है मेरी?
Yes, Hamza?
अब मैं कह रहा था
हमजा थोड़ा जोर से बोलें.
mass resist change and also inertia.
Okay. ठीक है. Okay. So, हमने डिस्कवर किया था कि मास की डेफिनेशन हमने डिस्कवर की थी इन योर फर्स्ट चैप्टर कि मास इज अ मेजर ऑफ inertia of a body, right? So what is inertia? Inertia means के resist, ठीक है? It basically means laziness, right? Let's imagine you're waking up on Sunday morning, right? This is your bed, and let's imagine if I draw Hamza over here. This is Hamza, right? Hamza is sleeping over here. Right? If I wake Hamza, if let's say if Hamza's mommy wake him up on Sunday morning, he would say, "No, I just want to stay asleep, right?" So इसकी जो हमारे पास current state है, that was basically sleeping, and he wants to continue to sleep, right? That is inertia, right? Imagine if a body is at rest, ठीक है, it wants to stay in rest, it doesn't want to move. If body is basically moving, right, in this direction, and you want to stop it, it would basically make sure to keep on moving in this direction. ठीक है, हमने एग्जांपल देखा था, we saw the example of a bus, right? We saw the example of a bus, and let's imagine this is Azan over here. Azan is standing in the bus. Let's say, ये समझो, let's say the bus driver saw the bump over here, saw the basically a ramp over here. He applied the brakes, right? So Hamza ki body, basically the bus was moving at a speed of 20 meter per second. So since Hamza is standing inside the sorry, Anas is standing inside the bus, so he would basically also be moving at a speed of 20 meter per second. Bus ने brakes लगा दिए, the speed became zero. At this point, the speed became zero. But Anas' body would basically want to move at constant speed at 20 meter per second. That is why you have a jerk, right? You basically undergo a jerk when the brakes are applied. The body wants to keep on moving, right? It wants to maintain that state. It doesn't want to change its state. Okay. Similarly, so since mass, the body is composed of mass, so inertia आता है basically from property of mass, right? So we can define mass as a measure of inertia, right? Okay. So this point is explaining this case. If let's say a body is moving in a straight line, imagine this scenario. And if you apply the brakes, the body would want to move at constant speed. It doesn't want to stop, right? So you basically have a jerk on your body. Then you basically control using, let's say, a pole inside the bus, or you use your feet to basically stop yourself, right? Okay. So the greater the mass, the greater the inertia, right? So जितना बड़ा inertia होगा, it is more difficult to move. For this, let me give you an example. Okay, what happened over here? Imagine you have an elephant, right? You don't have an elephant. Imagine you have an elephant in the zoo, right? We have an elephant in the zoo, right? Elephant की मैंने बना दी है, right? Elephant come over here and it has its ears, and it has its leg and it has teeth, right? Right? Let's say if you want to, this is let's say if you want to move this elephant, right? Imagine Hamza goes to a zoo. Hamza wants to test this phenomena. Hamza wants to apply a force on this elephant, right? Now, as compared to this, we have another scenario over here. Let's say this is Anas over here, and let's say we have Ruba over here, right? Ruba wants to, let's say, push Anas, right? So, which object is easier to move, elephant or Anas? Imagining Anas is a smart person and he weighs around, let's say 55 kg, and the elephant weighs around 5500 kg. So, which thing is easier to move? Which object is easier to move, elephant or Anas?
Unless
Anas, right? So you can just compare this, right? दोनों रेस्ट पर हैं अभी, दोनों रेस्ट पर हैं, right? They are standing over here. They are standing over here, right? So you can compare this. So inertia क्या होता है? It basically resists change, right? So inertia is a property which resists change, right? So since elephant and Anas were standing, it has stationary values, so they would want to stay at rest, right? But again, if you apply a force, this force is enough to keep basically push off Anas, but it is not enough to push off an elephant, right? So यहाँ पे इसका inertia is huge. So the inertia of elephant, this is inertia of elephant, and this is inertia of Anas. So inertia of elephant is way greater than inertia of Anas, right? This is the idea of inertia and mass relation, right? Okay. So I hope it makes sense. And just this is an experiment which you can do at your homes. Just take a cardboard, ठीक है, or let's say a wooden cardboard, and place a coin over here, right? And you can just place this experiment as it is shown over here. If you quickly basically apply a force in this direction, what would happen? The coin would remain stationary, ठीक है, but this card would basically come over here, right? ठीक है, keeping in mind कि आपने motion बहुत तेज किया है, keeping in mind कि your speed is pretty great, right? So this coin, which was at rest initially, would basically again try to maintain at rest state, right? So this basically shows the inertia of a body tries to resist change. If it is at rest, so the coin would again want to stay at rest. It basically won't have to change its basically state. ठीक है. So this is one of the experiments which can show you relation of inertia and mass. Okay. Does that make sense? If it makes sense, give me a thumbs up. This idea is pretty important, right? ये आपके आगे तब चलेगा in your next future chapters. So make sure that it is pretty clear over here. Okay. It makes sense to everyone. Not Mashal. Okay, it makes sense. Mashal also. अच्छा री. So Newton's first law हमने पढ़ लिया. We studied के we wanted let's say inertia as a property which we measured over here, right? So what happens ke it basically said ke let's imagine if you're sitting at your seats or sofa or let's say any question, okay, you're sitting on the ground also, you're stationary right now, right? So your body would basically try to maintain the state of rest. If I want to push you off, let's say if you have a kid, if you have a let's say a brother or a sister, right, who is teasing you right now, they would push you off, right? If they push you off, your let's imagine you have a lesser mass like Anna, right? This experiment over here. So you would be easily be toppling down either to your left or to your right or to the front or to the back, right? But if we have a let's say an elephant, right, which we saw, so it won't basically be moving, right? So inertia की property and mass relation ऐसे होता है. So what does the Newton first law said in a summary? कि अगर object is at rest, it would try to remain at rest, and object at constant motion will try to move with constant motion until a force acts on it to change its state. That is the summary of Newton's first law. अच्छा जी, अब हमने ये पढ़ लिया. अब we are gonna relate force and acceleration, right? ठीक है. अब ये लर्न किए, हाँ, कि अगर हमने पढ़ ली कि व्हाट आर द स्टेट्स दैट आर रिक्वायर्ड फॉर causing a change in state, right? Let's say if you are at rest, how can I make you walk? How can I make you basically, let's say, run? If you are at constant motion, how can I basically stop you, right? So for starting a motion or for stopping a motion, you need a force. Does that point make sense? So that is the Newton's first law. So for initiating any motion or stopping any motion, you would have to apply an opposing force or a starting force to basically start or stop the motion. अच्छा जी. Newton's second law basically talks about if your motion is actually happening, right? Let's say if the body is moving, how does the force that is applied on the object relates with mass and acceleration, right? Imagine this. You have a box over here, box A, and this is Mashal, right? Now Mashal is applying a constant force on this block, and the block is moving with constant acceleration, right? And this block has a constant mass that is equals to m, right? So just imagine this scenario. अब हमारे पास motion हो रहा है, the motion is happening. So we are gonna relate how is the force varying with the acceleration, right? ठीक है? That is the Newton's second law, right? So what does it say? It states the following. Let's talk about a definition of Newton's second law. Then we'll derive the formula. Can anyone tell me the definition of Newton's second law? Definition क्या होती है? What is the definition of Newton's second law? Yes, Vardha. What is the Newton's second law?
फोर्स इक्वल्स टू, नहीं फोर्स की डेफिनेशन ना, सॉरी,
Definition, not the formula.
मुझे इसकी डेफिनेशन नहीं आती.
Anyone else?
Sir, can I tell?
Yeah, sure.
So force is directly proportional to acceleration. So when force is applied on an object, the object accelerates in the direction of force. If the force is more,
Good.
the object will accelerate more, and if the force is less, the object will accelerate less.
Good. Perfect. Perfect. ठीक है. So let me just break down the definition into steps, right? ताकि it's easier to remember what is the definition. Imagine this block A. It has a mass m, right? So if you apply a force of F newtons, right, on a mass, on a block of mass m kg, right? So what would happen? An acceleration would result as a product, ठीक है, with the direction aligned with that of the force F, right? So up, what is it saying? It's saying as following, right? If you apply a force F on an object of mass m, so an acceleration takes place, ठीक है, which is in the same direction as of the force. You can see कि force का direction हमारे पास यही है and acceleration का direction हमारे पास same है. So these both vectors are parallel to each other. ठीक है, this is pretty important over here, right? So this is your Newton's second law of motion. ठीक है. So how do I define it? Basically, formula wise, it is as follows. And we basically came to a conclusion over here. Okay, if you apply the greater the force, the greater the acceleration, right? So the force and acceleration is highly proportional to each other. That is one relation. And we have seen another relation from the mass. That is, so greater the mass, lesser the acceleration. ठीक है. So if I try to link these two formulas, if I sketch them out, let's imagine this is your force F over here. It is in newtons. And this is your acceleration, which is in meter per second square. If I plot it out on a graph, this would be a straight line. That says that it is directly proportional to each other, right? So if the force increases, the acceleration would increase. If the force decreases, the acceleration would also decrease. Okay? That is what a direct proportional is. Okay? Now we have seen inertia, right? So the greater the mass, it is difficult to move it, right? The smaller the mass, the easier to move it, right? Which we have seen from elephant and another example, right? So this thing is basically inversely linked to another. अच्छा, यहाँ पे हमारे पास मास है. So mass is independent quantity, so it comes on x-axis, and acceleration is dependent upon mass, so it comes on y-axis, right? This is pretty important over here. So this is an inverse relation like this, right? So how do you read this graph? If you increase the mass, you can see that the acceleration is decreasing, right? And if you decrease the mass, you can see that the acceleration is going to increase. ठीक है? That is an inverse relation. So if I combine these two formulas, I get the following relation. That F is proportional to MA, right? Does that make sense? So if I just analyze these two things, if I just think, let's say acceleration हमारे पास नहीं है, it is not here. So this is stating कि force is proportional to mass. ठीक है? If I analyze the effect of what? If I analyze the effect of acceleration and mass, ठीक है, let's imagine हमारे पास force is equals to 1, right? It's not there, it's just 1, right? So that will give you कि acceleration is inversely proportional to mass. ठीक है? So both the conditions are getting satisfied over here. ठीक है? So we have now this relation over here. ठीक है? So if I remove the sign of proportionality, I will have a constant, right? So therefore I have F equals to K M A, right? Which you can see over here. So first of all, we had this relation over here, right? Achari, so now we did experiments. Physicists basically did some experiments and they came to a conclusion, okay, for a force of 1 Newton, right? You would have to apply the force of 1 kilogram, sorry, 1 Newton on a mass of 1 kg. And the acceleration produced is also equals to what? 1 meter per second square, right? So if you put in the values in this equation, you get 1 equals to K times 1 times 1, right? So what does K comes out to be? K comes out to be 1, right? So you can put this value of K over here into this formula to get your final formula. And therefore, you had the following relation. So we had this F is equals to K constant times mass times acceleration. Since we came to a conclusion from experiments, हमारे पास K is coming out to be 1. Therefore, the Newton's second law comes out to be as follows. That F is equals to mass times acceleration. Right? So this is your Newton's second law of derivation. ठीक है? Just give me a thumbs up if it is clear to everyone, the definition and the derivation. Okay, it's clear to Ruba, it's clear to Mashal, it's clear to Ryan, Hamza. What about May? It's clear to Azan. It's Azan, not Anas. Sorry, I thought it's Anas. Maeve, it is clear or not?
I didn't get it.
Can you speak loudly?
I didn't get it.
You didn't get it? What part?
No. Yeah, this part.
Can you speak loudly and just identify step number third, step number four, which was not clear?
Second one.
I'm not able to hear you.
Second one.
Second part. Okay. Huh.
Yeah.
So for the second part, just see this experiment, right? So this was mass 2. This was mass 1, right? Okay. So let's imagine we are applying a constant force on both of them. Okay. My force is constant, right? It is constant. Let's make it to a value of, let's say, 50 newtons. It's constant. It's not changing, right? So at this force, okay, obviously when I apply the force, the body should also accelerate, right? This is by from Newton's second law, right? So if you just compare, if you just compare this relation, right? Compare this relation of acceleration and mass. Okay, so I was just saying, yeah, let me just get to the last point. So can anyone tell me which object is easier to move? Anas, right? Anas would is easier to move. So which acceleration would be greater? So obviously acceleration of Anas would be greater than acceleration of elephant, right? So now, however, Anas had a smaller mass, right? So smaller the mass, greater the acceleration. Bigger the mass, smaller the acceleration, right? So it is an inverse relation, right? You can see over here, okay? The mass of elephant and the mass of Anas, okay? यहाँ पे if you relate this, mass of Anas was lesser than mass of elephant, right? So if we relate these two equations, we will see it is an inverse relation. That is why we came to this result from Newton's first law, that mass is inversely proportional to acceleration. Then combine these formulas into a single equation, and we got this particular thing. It should have a constant k, but through experiments, the k came out to be 1. Therefore, you have this equation k f equals to ma. Right? So now I would request you guys to just take out the calculators, your pencil, and your some of your attention. Okay, so this is just and definition over here. Newton's second law is what? K, it is mass times acceleration. So if you try to link, usually you have plot of force against extension or force against acceleration. ठीक है? So आपको एक graph दिए होंगे. तो say you can predict the mass of it, right? If I want to sketch the force and acceleration graph, so that would look like as follows. So you have force over here, that is in newtons. You have acceleration over here, that is in meter per second square. So it would be a straight line passing through the origin, right? So if you find the slope of this graph, what would you get? This is change in y, that is equal to change in m, change in a, and this is change in x, that is equal to change in f. So if you just see the formula, what formula do you have? You have f equals to ma. So if you try to relate, if you try to make m subject, you get k m is equals to force upon acceleration, right? But from this graph, your slope is coming out to be what? It's coming out to be change in acceleration upon change in force. So is it equal? Is it equivalent to mass, or is it equivalent to reciprocal of mass? Can anyone tell me how can I relate this thing with the mass? How can I relate this thing with the mass? Just compare the formulas and what are you getting from on the right side? Yes. Anyone? Azan?
सर रेसिप्रोकल मिल रहा है.
Reciprocal मिल रहा है ना? So if you see you are getting delta A over delta F. So that will give you 1 over mass, right? So if you rearrange the formula, if you do cross multiplication, you get the following thing. Mass time delta acceleration equals to delta F, right? So अब ये formula map हो रहा है इसके ऊपर, right? So when you find the slope of acceleration against force, you get the slope, ठीक है? So that is equal to the reciprocal of mass, ठीक है? So Abhi, keeping this in mind, start solving this question. I'm gonna give you guys 3 minutes to solve. We have 3 minutes to solve this question. So what are you giving over here? You are given the following things. Just compare things what are given over here. You're given this. We're given the mass of an object is 2 kg and the force that is applied on the mass is 5 newtons. Okay, this is F1 and your F2 is given to be as 9 newtons. Right? In the part A, you want to find what is the resulting force. And in the part B, you want to find the acceleration. Right? So think about this is your block M that has mass of 2 kg and okay, so this is basically is having constant force F1, that is 5 newtons. And after certain, let's say point B, the force is increased to 9 newtons. Go to find the resultant force, right? And then find the acceleration. Solve it out. You have 3 minutes.
So for the resultant force, I have 4 newtons, and for the acceleration, I have 2 meter per second square.
Good. Right? I believe everyone is getting the same answers. If your answers are matching, give me a thumbs up. If your answers are matching with Mashal's answers, give me a thumbs up. Okay, good. Good. That's good. That's good. Okay. So yeah, let's solve it out. Let's solve it out and it should give you a great idea. And for part A, so what is happening over here? You have the block A. Okay, let's this is point A, and the block is going towards point B, right? So initially it had a force of F1, right? That was 5 newtons. And the force will increase to initial एकदम से force में increment किया of to 9 newtons. Obviously, this increment would lead to acceleration, right, of the object. So we want to first of all find what is the resultant force with which the object basically is moving with now, and at at the corresponding resultant force, what is the acceleration, right? So we want to find these two things. So what is going to be the resultant force? It is going to be the change in force, right? That is going to be F2 minus F1. So that is going to be 9 minus 5. Therefore, the resultant force is coming out to be 4 newtons. Okay? And I hope it is same, right? And for part B, you need to find acceleration. So for acceleration, we have Newton's second law of motion, that is F equals to ma, right? We want to find acceleration, it becomes F upon m. And you know the mass of the object, that is 2 kg, right? Just put in the values. This is going to be resultant force, right? So that is the force that caused the acceleration, right? So going to be 4 upon 2. Therefore, you have 2 meter per second square, right? So these are your answers. I hope everyone is getting the same answer, right? Okay. So now we're starting with Newton's third law of motion, right? So can anyone give me a rough idea what do you know about Newton's third law? Yes, Mashal.
Sir, Newton's third law is that like जब एक force
Yeah, sure.
मैं मशाल नहीं हूँ
What the sure, speak up.
जी
Yeah, I
सर
know you're
तो
excited.
जैसे
Yeah.
इट्स ओके जब एक सर अकर होती तो वो it doesn't occur like in single, it occurs with a resultant force as well.
Okay. Good. Okay, so Mashal also wanted to tell the answer. Mashal, you can go on.
So the third law of Newton states that every action has an equal and opposite reaction. So when we apply a force on an object,
Okay.
that object will push or pull back with the same amount of force but in an opposite direction.
Yeah, that's good, right? So iska I gave a very simple example, right? Let's just see the example. Let me show up my skill, right? And let me just draw the ground over here, right? Okay, it's too big. This is the ground over here, and imagine this is the wall, right? Not imagine, just think that this is the wall over here, right? This is the wall over here, And this is Azan standing over, right? Let me just make him closer to the wall. Let me make the wall correctly to just show the three-dimensional sides. Right, these are the walls. It's a brick wall, right? So Azan is basically, let's say, standing over here, and Azan wants to test his limits, right? Azan throws a punch. Azan throws a punch at this basically this wall, right? Let me just throw a punch. Okay, so he applies a force in this direction. So what happens, Azan, then? If you want to smash this brick wall, right? So what would happen to your hand? Yes, Azan. Azan is here or not? Is Azan here? Or are you guys just chilling out, right? Azan, am I audible? Hello. Okay. I believe I'm audible and okay, he's having some connectivity issues. He just okay, I guess he's trying to join from another device. Okay, so imagine okay, this is Azan and he tries to basically apply a force, right? He tries to apply the force in this direction, okay? So what would happen, Vardha? Would he be able to break the brick wall?
Yes,
Yes,
sir. अगर वो
yes, if he is a Superman, right? Yeah, obviously yes. If he is a Superman, right? So obviously he won't be able to crush this in real life, right? So why? If you just let's say zoom in over here, if I just zoom in over here, what would happen? This is the brick wall, right? This is the brick wall over here, and this is basically Azan's hand, right? And he's basically trying to smash this. So what happens? Basically, when you apply the force in this direction, okay? So the atoms inside this particular brick wall at this position, they are compressed, right? So they're compressed by little amount. So let's say he's applying a force in this direction, right? So the wall also apply the same force, but in the opposite direction, right? Does that make sense?
सर
So
वापस रिपीट कर सकते हैं
I'm just saying, let's say this is Azan's hand over here, and Azan is trying to basically he punches the wall with the force F, right? So what does it do? It basically, if I zoom in further, this is the wall over here, ठीक है? So इसके atoms थोड़े compress हो जाते हैं, right? Let's say these are the atoms over here, they are compressed, and let's say these are the atoms which are normally over here, right? So these are the atoms which are closer to this particular point of contact. So the atoms are compressed over here. So when they basically are having a force of F, so they are compressed. Imagine you're sitting on the sofa. Your sofa cushion basically compresses, right, when you sit down. So just imagine this: ki when you punch the wall, so the atoms are so basically squashed, compressed by very little amount, right? So then, as a result, they also pushes you back, right? Pushes the hand back to again regain your original position, right? So negative F means K, they're providing the equal but force in the opposite direction, right? Does that make sense?
यस
So we have a couple of
यस
force. One force is in this direction, okay, which was by Azan, right? And the other force is basically in this direction, which is a force of negative F. It is by the wall, right? So these pairs of forces basically explain the Newton's third law of motion, right? These pairs of forces explain Newton's third law of motion, right? So now let's go to the definition. Okay, now let's try to see. Okay, what are we trying to study? Okay, so now let's skim the first of all the steps one by one. Okay, so this is Newton's third law of motion, which states that force never occurs singly over here. That means कि whenever you apply a force on an object, that exists always in pairs, right? Why is that? If you just see this example over here, जो हमने बनाया है, so when Azan applied a force, the wall also applied the force in negative direction. ठीक है? So there's a couple of forces. So forces exist in pairs. ठीक है? Okay. So for example, when you step forward from rest, your foot pushes backwards on the earth. Sorry. And the earth exerts an equal but opposite force on you, right? So imagine you're standing on the floor, right? Let me draw a foot. Let's say this is one of the foot over here. You're standing over here, right? So this is your force. So you're basically applying a force that is on from your foot to the ground, right? So the ground, the earth is also going to apply opposite force in the opposite direction, but of the equal amount. Okay. So that your foot is stationary over here, right? So always the forces exist in pairs. So this particular force is called contact force, right? Which you would have studied before in the first types of forces हमने पढ़े थे हमारे पास, ठीक है? So this is called a contact force, right? So then we have an example of the book over here, right? So let's see this example. What are they showing over here, right? So this is, let's say, imagine this is your physics book, right? This is your physics book, right? It's lying on your table, and you just basically finished studying, right? Now you're observing the book over here. You're observing the types of forces acting on the book, right? So can anyone identify the types of forces acting over here? It's already there, but can you just explain? Is it correct or not?
The gravitational force.
Gravitational force. Okay, how is it acting?
Sir, the earth, like the gravity, I guess, pulls on the book.
Good.
और
And
फिर contact force भी है जब
perfect.
book के साथ table के साथ लग रही है तो the book I guess force puts applies force on the table तो
Good.
table भी book पे लगाती है.
Good. Right. So yeah, she is correct. So first of all, we have one contact force which we have already seen, right? So this is the point of contact. We assume कि हमारे पास all the mass is at the center of the book over here. We assume that this is the center of mass. We'll see what is center of mass in a while. So what is happening over here? This is the push of the book on table, right? So the book is trying to compress the atoms near the table over here, around here, right? So what happens when they slightly get compressed? They also provide the opposite force, right? So they also provide then a push of table on the book, right? If it is F, this is also F, right? So they are equal in opposite direction. If you add it up, they will add up to zero, right? So if you add, let's say, these forces, they will have to add up to zero newtons. That is the reason that the book is stationary over here, right? It is not moving. There is no resultant force, right? If there would be any resultant force, if your resultant force would not be equal to zero, then you can apply Newton's second law to basically get the acceleration with which your book is, let's say, falling down, or let's say it's being dragged. So you can find your acceleration using this formula, which we have seen in the last lecture, right? I hope it makes sense, right? Now, this is not just one pair of forces available over here. We have also the weight, right? So let's imagine this is the center of mass of the book. So this is the weight component of the book over here, right? What is the weight? It is just the pull of earth on book, right? So pull of earth क्या होता है हमारे पास? It is a gravitational force. It is a gravitational force, right? So that is also called as weight. So imagine similarly, say if your book is getting attracted towards the center of the earth, the book is also trying to pull earth towards itself. But okay, since the mass of the book is too small, let's say the mass of the book is, let's say, 1 kg, right? Imagine this, it's a huge book. And the mass of Earth is 6.024 exponent 24 kg. It's huge, right? So there would be a force from the book to the Earth, but it would be pretty small, right? But there would be a force which is going to basically attract the Earth, right? So these are the pairs of forces which you can find on an object which is at rest. Okay? It can be a man standing, right? Man standing on the floor. So same couple of forces would be there, right? यहाँ पे contact force भी होगी onto the foot of the person standing, and there would be also gravitational force pair, right? So if everything is clear till now, give me a thumbs up. Give me a thumbs up if it is clear till now. Clear to Ruba, Hamza, okay, and also not to Maeve. What about Azan? Is Azan in the class, or he just logged in over here and he just is enjoying his snacks? Azan, are you here?
Yes, agree.
Okay, so is it
Yes,
clear or not? Is it
can you
clear? I
please
cannot
explain
hear you.
again?
Yes, Azan?
Can you please explain it again?
This part, this part or the definition part?
This.
Okay, this one.
This
Okay.
light.
So Maeve also didn't give me a thumbs up. Maeve, what is unclear? Is this example unclear or the definition of Newton's third law?
Just the definition.
Definition.
Yeah.
Okay. So definition of Newton's third law is as simple, right? Let me just write down the definition first. ताकि it makes sense. Okay. And let me write it down over here after this slide. Okay. Newton's third law of motion. Okay. So let me write down definition. I hope it will make sense after this. And let me choose this color over here. So it states what? To every action, there is an equal but opposite reaction, right? Up. Let me just give you another example for that, right? Imagine this is, let's say, Ali over here, right? Ali goes to, let's say, his friend, right? Let's say Farid. And let's say as a joke, Ali slaps him, right? Ali slaps him, right? So as a return of favor, he also got a slap, right? But in opposite direction, right? So you can imagine this. This is a couple of force, right? So when we discuss this example over here, imagine when Anas was trying to let's say punch the wall. So as when he was punching the wall, he basically applied a force F, right? Let me choose yellow highlighter. So he applied a force F on the wall, right? So as a reaction, the wall applied a force on his hands, right? That is force. Why is it negative? Because it is opposite in direction, right? So when to every action, so action was this was the action, right? The action was with the force F, and this is the reaction, right? From the wall to the hand, right? And the definition says that okay, to every action there is an equal but opposite reaction, right? You can see okay, the forces magnitude are same, right? It is also F over here, and it is also F over here, right? So the magnitude is same, just the direction of forces or the action reaction are opposite in direction, right? So that is the Newton's third law. Does that make sense now? May give me a thumbs up if it makes sense. Okay. Azan. Acha, so this example was unclear. So whenever you have, let's say you have a book over here which is stationary at rest, right? Azan, do you know how does contact force acts?
What's that?
Do you know how does contact force acts on on an object? So यहाँ पे basically let's say this is the point of contact which is this, right? This cross, right? So now there is a push of the book on table, right? So कुछ force लगा रही है book on the table. Since as the atoms of this table are being squashed, ठीक है? Imagine कि they're compressed by a very small amount. When they basically decompress, they will also provide the opposing force, right? So it's the Newton's third law, right? So this force is the action force over here, and this force is the reaction force over here, right? So they exist in pairs. Okay, the direction is the opposite, but the magnitude is same, right? So this vector is called the push of the table on the book, right? So this is the actions which was by the book on the table. This is the reaction which is the force by the table onto the book. Does that make sense?
Yes, sir.
Similarly, यहाँ पे let's imagine this is the center of Earth, right? This is center of Earth. So this is basically pulling the book towards the center of the Earth. That is also called the weight, right? So similarly, since the forces exist in pairs due to Newton's third law, okay, there would be always a couple of forces, okay, that forces would exist always in pairs. That is why we also have a vector which is basically being attracted towards this. So book is also attracting the earth by a force of W. The earth is also attracting the book towards the center of itself by a component of force that is equals to W Newton, right? ठीक है. I'm just saying that the mass of the earth is so huge, right? And the mass of the, let's imagine the mass of the book is 1 kg, right? So if you let's say leave the book, if you have a book and throw it on your, let's say on your bed, you would see that the book is falling down, but you won't see the earth moving towards the book because जो mass का difference है वो बहुत huge है, right? So the majority which you basically see is the book will be moving towards the earth, right? इसकी डिटेल हम पढ़ेंगे बाद में. So how is this true? We will study this in astronomy and cosmology part. Okay, what am I talking about over here? So does the couple of forces make sense? कि forces always exist in pairs. So whenever there is a book resting on the table, you would have you will have two types of forces. That is a contact force and the gravitational force pair. If it makes sense, give me a thumbs up. Okay, good. So since everyone is on the same page, now let's move on to friction, right? Yeah, good. So friction क्या होता है भाई? Who wants to explain friction? Yes, Mashal.
We can say that the friction is a force that opposes a surface moving or trying to move over another. For example, if we are moving on a smoother surface, we
Mhm.
would move for a specific time and we would move smoothly because there is less friction. But
Good.
when we try to slide over a wooden floor, we just stops after little time because of the more friction.
Good. Good. So anyone else who wants to answer the question? Raise your hand and answer. Anyone else? Okay. So I guess everyone believes that Mashal definition was more than enough to basically give, right? Okay, that's a good answer, right? So imagine, let me just give you importance of friction, right? Importance of friction, right? So imagine this is the ground, right? This is the ground over here. This is, let's say, the road, right? And let's say this is Hamza walking it. Okay, and I'm going to draw Hamza's foot as follows, right? These are Hamza's foot. I don't think they would be so huge. Just imagine this. This is Hamza's Hamza's pair of foot, right? So as soon Hamza is walking in this direction, right? Hamza is walking in this direction. So now we're talking about this is the road surface, right? This is the road surface which is made up of charcoal, which is pretty rough, right? And the greater the roughness, the greater the friction, right? So as soon as Hamza places his right foot and he basically applies a force in this direction, right? So his foot is applying a force in this direction, right? So friction क्या करता है? Friction basically applies an opposite force, right? Friction will be basically in this direction on his foot. This will be the friction on his foot. That's friction, right? So what happens? What is the benefit of this? Can you explain the benefit of this?
And sir, you don't slip.
Yeah, you don't slip, right? You don't slip. And your foot is basically stationary over here. Right? It does not move forward. Okay, so it's 0 meter per second. So in this case, हमारे पास the forward force है, that is equals to the friction force, that is the backward force. Therefore, if I want to find the resultant force using vector addition, जो हमने last class में हमने रिवाइज किया था, तो resultant force क्या होती है हमारे पास? It's just the direction wise vector addition, right? So plus F minus F friction, since they are same, this will come out to be 0, right? 0 newtons. That means your foot will be stationary, right? Okay, now imagine the same scenario, but on ice, right? So this is on charcoal, or you can say tar road, right? इसको tar बोलते हैं हम लोग. It's the cheapest quality of charcoal, which is used to make roads. Okay. Now let's imagine we have the following scenario. Okay, now time to walk on ice. Okay, so this is Hamza again. Let me draw Hamza again. Now Hamza is Let's say we're talking about after 5 years. Hamza is grown now, right? So this is the foot, which is exactly the same as it was, right? So this is the foot of, let's say, Hamza, right? And Hamza is enjoying the walk, right? Imagine he has no skates, right? He has no skates, no ice skates. He's just walking barefoot, right? Or let's say wearing shoes, right? The shoes which he was wearing on the road, right? Now he applies again a force F in this direction. So that basically step forward, right? But okay, what is the scenario in case of ice? We have no friction on ice, right? No friction on ice. So now what would happen? So this component will be basically जो हम बोल रहे हैं F friction is equals to 0. It's not here. It's not available on ice. So what would happen to Hamza now? Anyone? So let's find out.
Hamza
Well, sir,
will
he would.
slide past the ice.
Yeah, he will slip away, right? So if I want to find the resultant force, that would not be 0. That would be plus F minus 0. So you will have a resultant force of F on your foot, right? If you have a resultant force on your foot, therefore your foot will accelerate, right? That is equals to ma. Okay, and the acceleration of your foot will be F upon m, right? So he would slip by an acceleration of a, right? And he should have also some expressions also. Ouch, right? Who fell down. So this is the importance of friction. So friction is important, right? Imagine you're eating, right? And you're holding a spoon or a tea or a fork, right? Let's imagine you're holding glass to drink up some water, right? If there would be no friction, you would not be able to hold them up. How would you eat, right? So friction is also useful, but most of the time it's not useful, right? So imagine friction in your engine, right? So imagine your car is burning up, right? So let me just this was useful, right? Useful example. Now let's talk about the point, the place where it is not useful, right? Where it is not useful. Okay, that is in the engine of the car, right? So when the car is burning up the fuel and the car components are moving, right? So this is, let's say, engine. Imagine you're basically using a petrol, right? Or any source of energy, let's say battery if it is an electric vehicle. Imagine you're giving in 100 joules of energy, right? Using a petrol, any power source. And your engine is giving you only 21 joules as an output, right? So if you want to find the losses, so how many energy is lost? That is 100 minus 21. So you lost approximately 79 joules of energy in friction, right? So over here, it is not useful, right? Because you want your engine to be giving you almost closer value to the input energy as the output, right? So here it is not useful, but it basically in space. If you go to space, you won't have any friction, right? There is no air resistance नहीं होगी हमारे पास, ठीक है? So drag जो होती है हमारे पास, let's say if you are paragliding, ठीक है? Let's imagine if you're paragliding using a balloon, hot air balloon, right? And if you're paragliding like this, so you also basically face an opposing force that is called air resistance, right? So this is also one of the example of opposing forces. ठीक है? So friction is the force that opposes one surface moving or trying to move over another. It can be a help or hindrance, right? We have seen both the examples right now. You cannot walk if there was no friction, right? We have seen that our feet would slip away, ठीक है, when we tend to walk on ice. On the other hand, engineers try to reduce friction to minimum in the moving parts of machinery by using lubricating oils or ball bearing, right? Like, as I told you over here. So this was the output energy. This was the output of the engine. That was only 21 joules. Okay? And this was the energy which we supplied to the car, right? As a form of petrol or battery in form of electric vehicles, right? So we want these are the basically two dimension of friction. One is useful, one is not useful, right? अच्छा जी. So if I want to just define friction in a definition, single definition, that would be as follows, right? What is friction? Friction. So you would define this friction definition as follows. So it is an opposing force which occurs when two objects are moving on one another, right? Okay. So let me just give you an example. Just see this tire, right? This is a tire over here. Let me just draw a contact also. Okay, good tire. This is your tire over here, right? Let's imagine this is your tire. And your tire is basically trying to move. Okay, it's applying a force in this direction. Okay, it's applying a force in this direction, right? So the friction would be where? Where would be the friction acting? Yes. Where will the friction acting over here? It will be acting over here, right? In opposite direction, right? Make sense? To basically so that your tire does not slip away, right? Just imagine when it is winters and you're trying to basically make your basically hands warm or your body warm, right? So you rub your two hands against each other, right? You can rub your two hands against each other right now. You will feel that it is getting warmer, right? So the friction produces heat energy, right? And heat energy is also useful, okay, in winters, but in engine, in your cars, it is not desirable, right? If it makes sense, what is friction and the definition makes sense, the example makes sense. Give me a thumbs up. It makes sense to Ryan, Mashal, Ruba, Varda, Azan. Okay, not to Maeve. Maeve, what is unclear?
I didn't get the example that you explained.
Which example? This one?
The friction one. No, the other one.
This one?
Yeah, that one.
Okay, so it's pretty simple, right? Just stand up and start to walk. Maeve, just stand up and just put your feet again. Okay, just put your feet up in this direction. You would basically your feet will provide a force in this direction, right? Imagine if you're
Yeah.
standing on your room with there's carpet or let's say there's some marble over there, some flooring. There would be a friction force which will basically stop your feet. Just try to walk. You will see that. Okay. So this is friction force. Okay. So it's acting in opposite direction. You're applying a force in this direction. Your feet is applying a force in this direction, but your floor is applying a force in this direction, right? So this basically helps you to walk. Let's imagine if you're holding a tablet or a pencil on your hand, in your hand, right? So your hands, your fingertips are able to hold a pen, right? How? Because friction, right? There's a friction between your fingertips and the pen, which is basically keeping it together. Does that make sense?
Yeah.
Does that make sense, Maeve?
Yeah, it does.
And if you let's imagine if you walk on ice where there is no friction, so you would obviously slip, right? So slip kaise hoge? So this is basically the mathematics of that. Not the mathematics. This is the equation wise you can say proof that you would accelerate by acceleration of force over mass, right? That is the force that was applied by your foot, and you would slip away in this direction, right? And you fell down, right? So that is the importance of friction. Make sense, Maeve?
Yeah, I got it.
Give me a thumbs up if it makes sense. Because your voice is not so clear. Okay, good. ठीक है. So now we have some discussion over here, right? So let's discuss it out.
Yes, sir.
Okay, so now we're gonna talk about some types of friction, and which are available on road surface, on liquid surface, and on air surface, right? So any opposing force which tries to stop the motion is basically called friction, right? So let's just see this picture over here, and let me just first of all insert a blank slide over here, and let's copy this figure over here. Okay. Gee, so let's see this example over here, right? So this is an experiment which basically measures the force friction, right? So this is a spring balance. So what is a spring balance? Let me just explain the setup. So this comes in your MCQ, right? It's pretty much okay. Let me just save it first. And now just see this. This is a spring balance which is attached to a block of mass, let's say capital M, right? So, and P is the forward force which is applied by your hand, okay? And F is the friction force that is basically available between the table and the box, right? It is a friction force between the table and the block, right? So this spring balance basically it measures it measures the P, right? So how much force are you applying, right? It measures the P. You can see the readings over here. It is measuring the reading, right? It measures basically P in newtons, right? So let's say it was stationary initially and this spring balance is basically not attached. Let's say it is starting from 0 newtons. हमने कोई force initially लगाई नहीं है, ठीक है? Then we start to apply the force, ठीक है? Slowly, right? Let's say we make it first, let's say 5 newtons, right? And we saw okay, the block is still not moving. Now we basically made it to, let's say, 8 newtons, right? So we are measuring the force from here. We are seeing the force from here, right? This is our eye over here, and we're trying to see okay, what force are you applying, right? So now the force is 8 newtons. And at this particular point, the block starts to move. Okay? So you can just say K, the friction force is basically equals to 8 newtons, right? Why? Because when the P became greater than 8 newtons, let's say it was let's say it was now roughly around 8.1, right? 8.1 P it started to move. Let me rub this. And around 8.1 newtons, it started to move. So I can say okay, the forward force should be greater than 8 newtons for the motion to start. Does that make sense? For the motion to start, right? So this experiment can be used to measure the friction between the table and the block, right? So now keeping this in mind, let's read what is provided in the slides over here. Let me just quickly save it. Okay. So now again, it is just saying if P value is further increased than the value of the friction, it starts to move, right? So F has its maximum value that is called static friction, right? So static friction क्या होता है? This is a friction which basically needs to be overcome for the motion to start, right? Then you have dynamic friction, right? So what is dynamic friction? Dynamic friction is basically the friction which is occurring during the motion, right? So yeah, so you have two types of friction, that is static friction, and then you have dynamic friction, right? Right? So static friction is basically needs to be overcome to start the motion, right? And dynamic friction is the friction that is basically occurring on the block during motion, right? Okay. Now, friction drag. What is drag? Basically, it's act on an object or a vehicle which is moving through air, right? So that is called air resistance. Imagine the car is moving, right? The car is moving across the road over here, right? So it is applying a force F by the engine. The engine is applying a force of F newtons to basically keep it moving. There would be a constant opposing force to the car that would be air resistance, right? So this air resistance is also family of friction, because what is friction? It just opposes the motion, right? Okay. Similarly, friction drag, right? So drag is a force that acts in liquid, right? So imagine you're swimming, right? Imagine you're swimming over in a, let's say in a pool, right? Let's say you're swimming over here, right? So if you're applying a force in this direction to move forward, okay, there will be constant drag to your motion, right? That will basically be trying to stop you down, right? So friction is available in air and in also liquids, right? So drag increases as the speed of the object increases. and X to reduce the acceleration and objects to basically slow down, right? Similarly, drag, air, resistance, friction, they all are opposing forces, which tries to basically stop the motion, right? So this is the friction which needs to be pretty clear to you guys before moving on. If it is clear till now, kindly give me a thumbs up and talk about some types of braking distances and end the lesson, right? If it is clear till now, please give me a thumbs up. Clear to Mashal, Azan, Ryan, Rupa, Hamza. Okay, maybe I guess you joined 10 minutes later, so you can rewatch the recording. Okay, okay.
Yeah.
Huh. So you want to talk about this, these type of distances over here when you apply a brake, right? Imagine. Let me just draw the scenario for you guys. So you have the following scenario. Okay, you have the following scenario. So you have the road, right? And you see a bump. Okay, you see a bump over here. And this is the car that is basically being driven by you guys. It's not a hat, it's a car, right? So imagine you're driving the car and you're sitting over here on the steering wheel, right? Okay. And you see this particular bump over here, right? Now, after as you see the bump, okay, that is position A and this is point B, right? So after just seeing the bump, okay, seeing the bump on the road, till basically slowing down over here. Okay, you have basically these three distances over here. So you first of all think, okay, so what is the procedure for basically this entire process? You first of all think, so then basically we are thinking distance. And you basically do what? You apply the brakes. Okay. So if you combine the step 1 and 2, you get the overall stopping distance. Right? So just imagine that you're just seeing the speed breaker over here. So this is the speed breaker. You just saw it. Your brain basically makes decisions, right? And you calculate, okay, should I apply the brakes right now or not, right? So this is thinking distance is basically the distance traveled during your basically you're making a decision. Should I apply the brakes or not? It's a human reaction time, right? This is also called as human reaction time. Okay, how much time you basically take to make the decision, right? It basically varies from people to people. Imagine for a young person, right? It's small for a young person. Okay, it is relatively small, right? It's smaller, lesser as compared to old person, right? Because old person has, let's say, he has weaker memory, right? And he is basically weaker decision time, so it can vary from people to people, right? Then you press the brakes, right? So after pressing the brakes, it's between the car and the road, right? Then you have basically after applying the brakes. Okay, now you have applied the brakes. So now the decision, the destiny basically remains basically depends upon your vehicle and the road, right? So it is the distance traveled over the road after the brakes have been applied, right? And the car has been brought to rest, right? And if you basically want to combine these processes, process number 1 and 2 together, you get stopping distance, right? So it is a distance traveled that is actually taken to stop a car. Okay, that includes the thinking process and the braking process, right? So you have stopping distance, which is as follows. So stopping distance equals to what? It equals to thinking distance, TD, plus braking distance, BD, right? So if you want to just see an example over here, this is an example over here, right? So you have this thinking distance, right, on different speeds. Okay, let's say your car is driving at 30 kilometer per hour speed. So your thinking distance basically goes to 6, right? So these are basically values for a single, let's say, experiment. We have chosen a person who's done experiment here and got these results, right? And this is the braking distance over here at different speeds, and this is the total stopping distance, right? Let's analyze this particular part, right? So we have this following equation. Okay, stopping distance is basically what? It is the thinking distance plus the braking distance. So you are given what is, so we're talking about at speed equals to 90 kilometer per hour, right? So what is the scenario over here? You have stopping distance equals to the thinking distance for the person that was used in the experiment is 18 meters, right? And the braking distance which the car traveled after applying the brakes was 54 meters till it stopped. Therefore, the total distance which basically the process took is as follows. That is 54 plus 18, that is 64 plus 8, that is 72, right? It took 72 meters, so basically at a speed of 90 meter per second to bring the car to 0 meter per second. Air resistance and terminal velocity, right? So does anyone know about this phenomena? What is air resistance and what is terminal velocity? Just give me a glimpse, just a rough idea, if anyone knows about it.
Sir,
Yes, Mashal first. Raise your hand and answer. Okay. Yes, Mashal. Then Ryan.
Uh, we can say that air resistance is a type of friction that
Can you speak
opposes
loudly?
an action. We can say that air resistance is a type of friction. It opposes an action. As we fall from a high place, we are pulled by the gravity, and so the reaction force that we have is the air resistance. And where the terminal velocity is the maximum speed which can be attainable by an object as it falls.
Yeah, that's good. That's good. Yes, Ryan. You want to add on?
sir, air resistance is like it opposes the motion. So like if anything is falling from in the air,
Yeah. Okay.
the air will produce drag.
Hmm. So you can say sort of opposing force, right? So, what about terminal velocity? Any glimpse on terminal velocity?
The
Yes, Khuzaima.
terminal velocity is like constant velocity. When an object is falling and it reaches like I guess a terminal speed, so it gets like terminal velocity.
Yeah, that's good, right? That is good. So now let's think of a experiment, right? Let's think of a practical scenario. Okay, let's say we're doing bungee jumping, right? Let me show off my Picasso skills, right? I believe now everyone is a fan of them. Is a fan of my skills. So imagine this. Okay, you have a hot air balloon over here. Okay, and this is your hot air balloon. Let me draw the balloon. Okay, so you are basically jumping from here, right? You are basically doing paragliding. Okay, and you have a parachute in your backpack. And when you think you're near the Earth's surface, you will open the parachute, right? Let's say this is Sir Khuzaima, right? And he's trying to prove a point, right? Achari, now think I'm just free falling, right? I'm just falling in air, right? Without any parachute right now. So what is the force that is pulling me down?
Gravitational force.
Yeah, that is my weight, right? So my weight is pulling me down. What force will try to stop me?
Air resistance.
Yeah, so you have opposite force over here that is called air resistance, right? So my W is corresponding to weight of my body, right? Weight of my body. And what is the air? AR corresponds to air resistance, right? Okay. So now you are basically, let's say you jumped from your hot air balloon and now you're accelerating, right? You're accelerating downwards, right? Okay. So what would happen initially with the weight? Okay. So there are three phases over here. आपका first stage is when your weight is greater than air resistance, and when your weight basically becomes equal to air resistance, right? Okay. अच्छा जी. So now think of these stages carefully. कि हो क्या रहा है आप? So let's talk about my stage one. Okay. This is stage one. Let's say. So my weight is greater than air resistance because let's say when I jumped from the hot air balloon, obviously I would accelerate downwards, right? Because मेरे weight का जो force है, let's say my weight is coming about to be 800 newtons. Okay, and initially my air resistance value is 200 newtons, right? So it is the drag, it is the opposition of air particles against my body, which is trying to stop me, right? So now I have 800, which is greater than 200, right? This is my case over here. Okay. So I am now accelerating. This is very important over here. When my weight is greater than air resistance, I am accelerating. Why? Think about Newton's third law, Newton's second law. Let me just erase this. Newton's second law. So what is Newton's second law? How do we relate force and acceleration? It's the resultant force equals to mass time acceleration. Yeah. So we have someone over here with infinite mobility. Can you share your name? Maria or Iman?
Maria.
Maria. Okay. Welcome, Maria. So Maria, we are doing basically forces, dynamics. We have started the chapter. So we are doing air resistance and terminal velocity, right? So whenever you have a query, just raise your hand, okay? Okay. So up, how do I find resultant forces? You have one force that is downwards, okay, and you have one force that is upwards, air resistance, right? Your entire body is basically moving downwards, okay? So acceleration direction आपके पास क्या है? It's downward, right? So you would have to find resultant force. Okay, what is the remaining force after I remove the air resistance that is causing my acceleration? Does that make sense? So if I add this down over here, that weight minus air resistance is the remaining force that is causing my body to accelerate, will give me the final value of my acceleration. If this equation makes sense, give me a thumbs up. If this equation makes sense, give me a thumbs up. It makes sense to Mashal, Ruba, Varda. Okay.
सर वापस एक्सप्लेन कर दें
Just imagine this. This is your body. ठीक है, body, let's say खुजामा K, and आपके पास एक force नीचे लग रही है, the weight, and you have one force at the top. ठीक है, you want to find the resultant force. ठीक है, and I'm taking this direction to be positive. ये direction positive है. This direction is positive. ठीक है, so I have positive weight and negative AR. ठीक है, because air resistance is in the opposite direction. तो ये direction negative है. ठीक है, so I have weight minus air resistance. So I will have 800 minus 200 equals to mass times acceleration. So it is the 600 newtons that is remaining, that is being applied on my body, जो मुझे accelerate कर रही है, right? So I have 600 equals to mass time acceleration. So if I want to find acceleration, that comes out to be 600 divided by mass of my body, जो भी मेरी mass है body है, ठीक है? So that will give you the answer in meter per second square. So does that make sense? If it makes sense, give me a thumbs up. I will just recognize किसको समझ नहीं है. Does this make sense? Okay, it makes sense to Mashal, Ruba. Okay, it makes sense to Varda, Hamza also, not to Maria, not to Maeve, not to Ryan. Okay, let me just insert a page. I'm just saying this. You have a body, okay? We have seen free body diagrams. We know how to add forces. We have a body K, right? We have just two forces acting on the body. That is the weight of the body and the air resistance side. अब मैं जो डायरेक्शन ले रहा हूँ, if the force vector is downwards, I will take it as positive. If it is upwards, I will take it as negative. ठीक है? So I want to find the resultant force. What is the resultant force? It basically removes the opposing forces. ठीक है? It finds कि कितनी force, how much force is left, which is causing my body to accelerate downwards. ठीक है? So I will remove the force which is blocking my path, right? So if I just find the resultant force, that is going to be RF. So my resultant force is going to be plus W. I'm just adding them, right? जो हम कर चुके हैं पहले. Plus negative of air resistance, right? So my resultant force is coming out to be weight minus air resistance. Now does this make sense? Now does this part make sense? Thumbs up.
Yes, sir. Yes, sir.
Okay. Maeve, make sense? Okay, good. So I'm just saying कि जब मैंने jump करी from the hot air balloon, so initially I would accelerate, right? I would basically move pretty fast through the air, right? Because I am accelerating by a value of this. It's just a hypothetical values, ठीक है? It will change according to questions. ठीक है? This is case one. So initially I would accelerate, ठीक है? So now let's reach case number two. ठीक है, there would be a point जहाँ पे मेरा weight और air resistance would be same, right? That is case number 2. So let's discuss that case number 2, right? Okay. So this is some fun activities for, you can say, foreigners. Pakistanis also do it, but in northern areas. Okay. Let's imagine the case number 2, which is saying that now your weight is equals to air resistance, right? Now imagine this is your body, K. Now this is your weight, and this is your air resistance. Okay. So now if I want to find the resultant force that is causing my body to move down, okay. Now imagine कि मेरे पास my W is also 600 newtons and my air resistance is also 600 newtons, right? So I want to find, okay, what is the Newton's second law? That is force equals to mass time acceleration. You want to find resultant force, okay? You want to find resultant force. That would be weight. We have seen that, how do we add up, right? That is going to be weight minus air resistance. That is going to be mass time acceleration. So this is also 600. This is also 600 equals to ma, right? Make sense? So now this part goes to what? 0. Okay. So if you want to find acceleration now, this comes out to be 0 upon m, that is 0. So your acceleration when your force, your air resistance is same as your weight, is going to be 0. That means at this particular point, your velocity, your speed is going to be constant. Does that make sense? Does it make sense? If it makes sense, thumbs up. So let me just read it out कि क्या लिखा हुआ है यहाँ पे. So as the object accelerates, the air resistance opposing its motion increases, right? So it will increase till it basically becomes equal to your weight, right? So this reduces your acceleration. You can see that initially your acceleration was 600 upon m. Okay, it was a huge value. Now it has gone to 0. So it has reduced, right? It was initially positive. Now it has reduced to 0 at the maximum point when your weight is same as your air resistance, right? So eventually air resistance acting upwards equal the weight. That is important over here. Air resistance equals the weight over here. Okay, and then the resultant force acting on the object is 0, right? Then at this particular point, your object falls at constant velocity, which is called terminal velocity, right? Okay, so what happens over here if I draw the graph of speed time graph? Let me just draw the speed time graph. How will it look like? It will look like this. Okay, this is your time, this is your speed. So initially it would accelerate, it would go to 0. It will basically become constant, right? So this was your, this till this particular point, it was your case 1. Okay, and after from point A to point B, it is case number 2, right? Make sense? तो यहाँ पे आपके पास your weight is greater than air resistance. At this particular point, from point 8 onwards, your weight is equals to air resistance. ठीक है? Imagine this body. This body is falling. This is the weight, and this is the air resistance. ठीक है? Does that make sense? Does this idea make sense? If it makes sense, give me a thumbs up. And if basically जो thumbs up नहीं होंगे वो पूछ ले मुझसे. Yes, Mashal.
Sir, can you please explain it again?
What graph? This graph?
Yes, the graph.
Okay. So you can see कि what is this graph showing? It is showing increasing speed, right? हमने पढ़ा था in your chapter 1. How do we plot graphs? This is increasing speed, right? Right? This is increasing speed.
Yes, sir.
Okay. And we know how do we get acceleration? From the slope, right? So your acceleration is going to be basically increasing. Does that make sense?
Yes, sir.
Okay. So it basically goes to maximum value and it becomes constant, right? So यहाँ पे your acceleration is 0 because इसका slope is 0. Because if you find the slope of a horizontal straight line, the slope is going to be 0. Right? Does that make sense? Yeah. Okay. This is showing your acceleration, your body is accelerating, right? This is showing your body is accelerating. And this part is showing your body is not accelerating. Does that make sense? If it makes sense to everyone, give me a thumbs up. Okay, it makes sense to Hafza, Ashal, and Ruba. Maeve, is it making sense?
Yes, sir.
Okay, if you have question, please ask. If anyone has question, ask, right? Just don't stay quiet. I just basically used the example using values that it makes sense to everyone easily, right? If I just read out these definitions, you guys would not understand, right? So we chose the example. I believe it makes sense now, right? Now you can just see this example. Okay, they are paragliding, okay, and they reach a point where basically they are moving at constant, they are at constant speed, right? So they can then play around with their bodies. They can make motions, right? They can form patterns. And if you want to watch videos, you can just go to YouTube and check out the pattern, right? You would observe that they would accelerate in the start, and then they would reach constant velocity just because they would be moving constant, and then they would open your parachute, and they basically fall down at a very slower speed, right? So they're playing with the air resistance, right? Okay, so now I believe okay, this is clear to everyone. Let's talk about circular motion, right? So if I just say this particular term, circular motion, what do you guys understand? What is circular motion? You can see this particular
Sir,
गोल घूमना.
गोल घूमना, okay, स्कर्ट पहन के, okay, ठीक है. Anyone else?
sir, because this is in the chapter forces, I would think that this is basically a force that acts on anything that's moving in a circular motion.
Hmm. Okay. Anyone? May if you want to contribute, what is circular motion? What do you get about it? Just give me your thoughts. Okay. Is Maeve speaking? I get Maeve is not responding. Yes, Ruba.
So basically, circular motion is when an object is moving in a circular path, and its motion is like said to be circular motion. And whenever an object is like in circular motion, a force is acting upon it, which is centripetal force.
Hmm. Good. Anyone else? That's pretty accurate. Anyone else? I just want some participation over here. I just don't want idle bodies to be standing, just sitting in front of your laptops or mobile just watching the lecture. Yes, Hamza. What is circular motion?
It's an object moving in an orbit, something like constant orbit है कोई equal distance पे हो जा रहा है.
Hmm. Okay. So if I now show you this, okay, just see this diagram first. Okay, they are trying to, it's competition that is throwing a hammer, right? So they move in a circular motion and just throw it away, right? So this circular motion which they rotate and it produces a certain force, right? So when they leave off the rope, it accelerates, right? So now let's see this. I want you guys to take 1 minute and skim this slide. Just imagine in your head, let's keep this competition and then try to relate how is this linked together with this particular last picture. Yes, can anyone analyze this figure 1.5.18? Okay, so let's start. I believe you have got some ideas कि हम क्या बात कर रहे हैं. So what is circular motion? ठीक है, so let's start with the definition. Okay, so it is the motion of an object around a fixed point. It is the motion of an object around a fixed point in circular orbit. Circular orbit. My spelling mistakes are occurring over here. At a fixed radius, right? At a fixed radius r, right? Imagine that this is your center of rotation. Okay, let's say this is the person standing which is rotating the rope over here, and this is the object which is rotating, right? So this is basically moving in a circular motion, right? So this is the rope over here, and it is moving at a constant radius r, right? This is r, this is radius r, this is radius r. ठीक है, and this motion produces a certain force that is called centripetal force, right? So what does centripetal means? Centri means, ठीक है, towards center. This entire term means basically towards the center, right? So the force which is acting toward the center of the motion is called centripetal force, right? Imagine this particular motion. So यहाँ पे जो this is, let's say, object B. The object B has a sort of a centripetal force which is keeping the object to move in a circular motion. That is called centripetal. ठीक है. So let's begin. I was just saying कि if you just imagine, let's say if you take a thread and at the end of the thread you basically put a metal block, right? Just start rotating it in a circular motion, right? You will feel a force on your hand, right? So that is a centripetal force, right? So when you start a circular motion, you will feel a force that is acting on your hand, right? So that is the force that is being applied by the object that is rotating in a circular motion towards the center, right? Let's say if you have a thread which you're rotating around us in a circular motion, so your center is your arm, right? So you will feel a force in your hand. That is called centripetal force, right? So centri means center and peter means towards, right? So centripetal means it is the force that is acting towards the center of the circular motion, right? Okay. So now there are some important points over here which you need to note. Okay. They are as follows, right? So let's say we are having a string which is whirling around in a horizontal circle. Okay. Let's say you are basically creating a circular motion like this using your arm. So you can see the direction of motion is constantly changing over here, right? You can see if you have draw better, draw basically the velocity over here. So you can see it's constantly changing, right? So you can see if you draw tangents over here. So let's the object is over here, the velocity vector is going to be here, right? If the object is here, the velocity vector is going to be here, right? And at A, it is along the tangent of A, shortly after it's B, along the tangent of B, and so on. It's just saying that it is moving around a circular motion. It crosses point A, point B. Let me name this point C, point C, point D, right? So it basically completes a circular motion in this particular orbit, right? And it is just saying, okay, if you just see, this is the force, centripetal force Fc, this is centripetal force Fc. The direction of motion, that is speed versus force, the angle is always perpendicular, right? This is going to be the force Fc and this is going to be the force Fc, right? You can see at every point the angle is going to be perpendicular, right? It is an important point which you will learn in your A levels कि ये angle की important होता है. Just in your O level, just remember कि the component of your velocity and your force are perpendicular in a circular motion, right? Okay, so now let's move on. If you have any questions, please raise your hand, ठीक है? If you are not asking questions, I am assuming कि आपको समझ आ रहा है. Okay. Yes. Yes, Vardha.
सर थोड़ा सेंट्रीपिटल फोर्स को जो डायग्राम थी उसको वापस समझा सकते हैं?
Okay, I'm just saying कि if you just recall this, just see this diagram, ठीक है? And this is the direction vector of motion, right? कि object up इस direction में कर रहा है. That is कि it has a velocity. It has a, you can say, component of velocity in this direction at point A. It has a component of velocity at point B in this direction. At point C, it is always tangential, like it is always tangential. Tangent क्या होता है? If you have a curve, so let's say if you want to draw tangent at point C, you draw tangent which basically touches this point C at a single point like this. Okay, so you can see okay, at this point, this arrow vector is only touching at a single point, that is point D. So it is always tangential, right? And if you see this particular force, the centripetal force, that is always towards the center. यहाँ पे center क्या है हमारे पास? That is center O. ठीक है? And if you see this force and if you see the direction of speed or motion, they're always perpendicular. They're always perpendicular. Okay, just keep this point in head. Does that make sense?
Yeah.
Okay. अच्छा मुझे बताएं कि imagine, now let me just say this statement, right? Imagine that you have a thread and you are rotating the object in a circular motion, right? And you are saying कि let's say use the instrument जिसने ना आपके object जो move कर रहा है in a circular motion, you measure the speed and you came to a result, you came to conclusion that your speed was constant, right? Your speed was constant, that was 10 meter per second throughout the motion, right? At every point in a circular motion आपने speed measure करी है, it came out to be constant 10 meter per second. Okay. Can I say this? If my speed is constant, I will also have a constant velocity of 10 meter per second. Is this true or not? If whoever answers this question will get a +1 in their upcoming test. I'm just saying कि if I say कि my speed of the object that is moving in a circular motion is constant 10 meter per second. Upon this, can I also say कि my velocity is also constant 10 meter per second of the object? If whoever answers this question will get +1.
क्वेश्चन समझ नहीं आ रहा, एक दफा रिपीट करेगा?
क्वेश्चन ये है कि मैं कह रहा हूँ कि जो मेरा ऑब्जेक्ट मूव कर रहा है, लेट मी जस्ट draw the diagram for you guys. You want to basically have a visual representation, right? Let me just draw that. Let's say if जो ऑब्जेक्ट मेरा मूव कर रहा है सर्कुलर मोशन, ठीक है, like this is your center. So let's say the object which is moving around the circle is basically this, right? If I say कि at every point, let's say मैंने यहाँ, this is point A, this is speed V, let's say this is point B, इस पे I was getting also speed V, right? At this point, this is point C, मेरी speed आ रही थी V, ठीक है, and at this point also I was getting a speed of D, ठीक है, V. So I'm just saying कि मेरा जो V का magnitude है ना, I'm just saying कि speed is constant, right? The speed of object is equals to 10 meter per second throughout the entire motion. So I can say कि my speed is constant, right? Now, can I say कि my velocity of object is also constant, that is 10 meter per second? Is it going to be
Yes.
constant?
Yes.
Okay. Those who say yes, raise your hand. Okay, Hamza is saying yes, sir, velocity constant रहेगी. Rupa is also saying sir, velocity constant रहेगी. Varda is also saying velocity constant रहेगी. What about Mashal, Rayan and Maeve? नहीं रहेगी. Okay. So who is saying कि नहीं रहेगी? क्यों नहीं रहेगी? Why will the velocity be not constant if you are saying कि Mashal, Rayan and Maeve, you are saying कि it's not going to be constant? Can anyone answer कि why? Okay. I guess no one is able to answer this. Okay, let me just start. Just imagine what is speed? Is speed scalar vector?
Scalar quantity.
Speed is a scalar quantity, right? It doesn't depend upon direction, right? If you just say कि it has a constant magnitude of 10 meter per second, yeah, that's okay. That's okay to say. We can say कि speed is constant. What about velocity? Velocity is a vector quantity, right? Which depends upon two things. It depends upon, first of all, the magnitude plus the unit, depends upon magnitude, and also the direction, right? You can see direction are changing over here. The direction are changing. ठीक है? Direction are constantly changing over here, circular motion. So you cannot say कि velocity is constant. You can therefore you will say कि velocity in a circular motion is not constant. Does that make sense? Because your direction of velocity is changing throughout the entire motion. It was like this here, it was like this over here, it was like this over here, it was like this over here. So velocity is not constant. However, the magnitude of velocity is constant. The speed can be constant, but direction is changing. That means your velocity is changing. That comes in your MCQ, right? Does that make sense? If it makes sense, give me a thumbs up quickly. I want to move on. Make sense to Mashal, Varda, Ruba, Maeve, Hamza. Good. ठीक है, दिस आर टिपिकल पॉइंट व्हिच पॉप्स इन योर एमसीक्यूज, सो मेक श्योर कि यू नो दिस. सो यहाँ पे लोगों ने यही लिखा हुआ है कि वेलोसिटी हैज बोथ साइज एंड डायरेक्शन, स्पीड हैज ओनली साइज. ठीक है, देयरफॉर you can see कि velocity speed in a same direction, and if direction changes, so basically velocity changes, right? It's just saying कि why is your speed constant and why is your velocity varying? Okay, just verifying that statement over here. So read it out on your own, and you can, if you have any questions, you can post them on the WhatsApp group. Okay. Yeah. So now read these 3 points. Okay. It is saying that you will need a larger FC. Okay. Let's imagine this is your circular motion. This is point O, and this is your circular motion, right? This is your circular motion, and this is your object moving, right? Now we're talking about the magnitude of FC. Okay, I'm just talking about what is the FC magnitude. How will it vary depending upon some test cases, some scenario, right? So the first scenario is this. So you will need a large force if your speed of the wall is increased, right? So let's say if you increase the speed, right, your FC will also increase. So it is stating that your FC is proportional to speed. If your speed increases, your centripetal force will also increase, right? And you will need a larger FC if your radius decreases. right? It is stating this is your radius. So it is stating your force of centripetal force is inversely proportional to radius. So if your radius decreases, you will need a larger force. Okay. Now they are saying how does the force relates with mass? So if you increase the mass, you would have to provide more centripetal force, right? So they are directly proportional with each other, right? Okay. So again, this is the definition of centripetal force. So it is the force that acts towards the center and keeps the body moving in a circular motion. That is called a centripetal force. Okay. And yeah, okay. It is just saying, okay, let's say now this breaks. Okay, let's say now this thing breaks. Let's say the person is rotating the object in a circular motion. What if this particular rope breaks? What happens then?
Where
So,
the
Raise a hand and answer. Yeah, raise a hand and answer. Yes, Mashal. Mashal wins. Yeah.
so if the stick or the string breaks, the object will move in the direction of the tangent.
Yeah. Okay. Good. Yes, Varda.
सर मैं भी यही कहने वाली थी कि
Okay.
उसी डायरेक्शन में बॉल या जो है वो ऑब्जेक्ट जाएगा.
Perfect, perfect, perfect. So it is stating this. Let's read this statement, which is pretty important over here. Should the force be greater than the string can bear, the string breaks, right? And the ball flies off with a steady speed in a straight line along the tangent. That is in the direction of travel when the string broke, as the Newton's first law of motion predicts. La la la, ठीक है. It is not outwards. Okay, these are important point. So let's see this. What is that saying? Imagine this is a circular motion. You can experiment this. You can experiment this with your with a let's say string and a small metal, not a metal ball, any rubber ball, right? Imagine this is your center, right? And this is your ball, right? At this is point A. Let me draw this is point B. This is point C, and this is point E. Okay, and at every point you would know the direction of velocity will be like this. This is B, and this is going to be the direction of B. यहाँ पे this is going to be direction of B. यहाँ पे this is going to be direction of B. Right? Let's say the spring broke at this particular point. ठीक है? Now the spring broke here. ठीक है? Let's say you are moving at a very high speed. They basically the string tension was not able to hold the string together, right? So the spring break from here, right? You guys said it would go in this direction. Okay, but it would not go in this direction. It would go in this direction. ठीक है? Until and unless other force acts on it to change state. ठीक है? Does that make sense? Does that make sense or not? Yeah. So the spring breaks. That's basically the thread breaks here. It will not go outside exactly. It will go in a resultant velocity direction. Right. This is very important over here. If it makes sense, give me a thumbs up, everyone. I lost your track of thumbs ups. Yeah, Mashal, Varda. It makes sense to Ruba. Okay. What about yeah, Hamza? समझ आ गया? ठीक है, good. So this is pretty important, right? I believe it is clear now. So let me just give you an idea. Okay, what we will do in next class, right? That is standing effect of forces. I want someone to explain. I want someone to give me an idea about this. Let's say I don't know anything about this.
सर टर्निंग इफेक्ट ऑफ फोर्स को टॉर्क भी कह सकते हैं.
Mhm. Just give me let's say a layman definition. If you want to explain this to a layman who doesn't know anything about turning effect of force, how would you explain that? Yes.
सर फोर्स की जो मोमेंट होती है उसको हम टर्निंग इफेक्ट ऑफ फोर्स कह सकते हैं.
Okay. Yeah. Okay. So imagine this particular pen, right? If you have a scale or any pencil in your hand, try to balance it out on your finger, right? Yeah. You can just see I need to find some point over here. Okay. No. Not able to balance it out. Yeah. So you can see if I just change my center, it would basically rotate, right? It turns. So this turning effect of force, right? With the forces which causes the motion, which causes basically movements, right? It's called turning effect of force. Okay. What is moment? Moment, you can see if you have, let's say my finger is the pivot. Pivot क्या होता है? It is the point at which the body is basically resting, right? Let's say this is my finger. If I'm resting my body here, okay, where is it? Okay, so if I just rest my body and the entire pen over here, so my finger is my pivot, and this is my basically my scale, or you can say the plank. It has some components, some moments, which will cause it to move clockwise or anti-clockwise, right? So this moment is called turning effect of force. I hope it makes sense, right? So let me just introduce in this slide क्या होता क्या है, and then we will dive deeper into the moments and the principle of equilibrium क्या होता है in the next class, right? So turning effect of force is called the moment of the force, right? As Vardha said, it is called the moment of the force, right? So it depends upon both the size of the force and the distance from the pivot, right? What is pivot, by the way? Imagine this particular scenario. Let me just draw a good scale. Okay, imagine this is your scale, which is balanced out over here, right? This is your scale, and this is the pivot, right? So pivot is the point at which your scale is balanced, right? So you can see, okay, let's say we have a mass m1 over here, and we have mass m2 over here, right? This is the center of the pivot, right? And it is at a certain distance also, right? You can see it is at distance, let's say d1, and this is at a distance of d2. Okay, so this particular mass m1 will try to cause the scale to move in this direction, and this mass 2 will basically cause the motion in this anti-clockwise, in clockwise direction, right? So these are called moments. Yes, Oba.
Sir, can I leave the meeting? I have another class. So should I
Okay,
leave?
sure. I'm just ending in 5 minutes. Okay, yeah, you can watch the
Okay.
remaining.
Allah Hafiz.
Okay, Allah Hafiz.
Okay.
Okay, does this make sense? Okay.
Yes.
So now it depends upon two things, right? That is how far away it is from the pivot and what is the weight of the blocks. That means how much force are they applying, right? That is what is the weight one. Let me just draw using highlighters. What is the weight one over here, right? What is the weight two? So it depends upon the forces also, right? This is the weight one, which is also a force. This is the weight two. So it depends upon the force magnitude and how far away they are from the pivot, right? So if I want to define this, the formula for a moment of a force. So let's take an example, like you have your doors. Obviously, you have doors in your apartments, right? You have a door knob, right? You can just easily close and open your door, right? Try to open the door from the center, right? Imagine you have a door over here, and this is your door knob, right? And at this particular point, they are fixed, right? They're fixed from here. Then you can open the door either like this, or you can close the door in this direction, right? I'm just saying, okay, after the class, try to open the gate from here, from this side. You would have difficulties opening it. You would have to apply more force. Think about that in the next class. I will ask the question, right? So what is moment? So moment is basically force into perpendicular distance from the pivot, F into T, right? So this is the formula of moment. That is going to basically multiply. You want to basically multiply the force that is applied times the distance from the pivot over here, right? Imagine this scenario, the simple scenario, which I want to explain. Imagine this, right? Let's say this is your block over, this is your scale over here. It is fixed from here, right? This is the pivot over here, right? This is the pivot over here. And you're applying a force in this direction, right? F. And this is the distance from the pivot, right? D. So you always want to take a distance that is at a perpendicular distance, right? So you should always have a 90-degree between the force and distance, right? So the moment of this particular scenario is going to be force into distance, right? That is moment, right? That is how it is basically causing a movement around the pivot over here, right? It is going to be a turning effect, right? It's going to cause a turning mechanism. Okay. And let's talk about the SI unit. Can anyone tell me what is the SI unit of moment from the formula? Just see the formula and tell me the SI unit. Okay, Newton meter, right? So you know, okay, force is measured in newtons and distance is length that is measured in meters. So therefore, the SI unit of moment is Newton meter, right? That is written over here. Okay, that is Newton meter. So if you want to define this moment, if you have a question in your exam of 1 mark in your theory, just write a definition. Okay, moment of a force is force time is the product of force and perpendicular distance from the pivot. That's it. You get 1 mark. Okay. So any questions till now? If everything is clear till now, give me a thumbs up. H is clear to Ryan, Varda. What about other kids? Hamza, Mashal, and Maeve. Is it clear till now? It's clear to Hamza. What about Mashal? Is Mashal here? Is she chilling out?
No, sir. The last one means the turning effect of forces and the moment was not clear.
Yeah.
The rest of them are clear.
Is it how is it not clear? If your question asked.
I didn't quite understand the whole point of the topic.
Yeah,
So,
just go and just play with your door. जो आपको बताया ना मैंने. This is homework. Let's see. Just
okay.
try to open your gate from the center instead of the doorknob. Okay?
Okay.
Okay. Okay. Yes, on an object which is let's say fixed from one point, right? So if I apply a force in this direction, so what does it do? It causes the object to turn, right? It causes the object to turn, okay, either clockwise or anti-clockwise, right? So this phenomenon is called moment. Okay. And how do I find moment? Moment is basically force into perpendicular distance from the pivot, right? So you always want to take a distance that is at 90 degrees with the force. Okay. That is very important. Then you derive the SI unit of moment. You know the force is measured in newtons, distance is measured in meters. So what do we get as the moment SI unit? That is Newton meter, right? Does that make sense to you guys? I believe it does because when I build up on this. Okay. If it is clear till now on the movement section, give me a thumbs up. Now I'm going to move on to the next part. It's clear to Mashal, Varda, Ayan. Is Ruba here? Is or Ruba chilling out?
Sir, I'm here.
Okay,
It's
okay, you are
clear.
okay, you are here. Okay, okay now let's do some example, right? So you did the experiment, right? You did the experiment with your door. And Hamza and Mashal said, okay, sir, if I apply the force, if I try to open the door from the center, Ryan also said that I would have to apply more force, sir. Okay. So let's talk about it, right? Let's see scenario A, let's see scenario B, right? Let's find the moment for scenario A. Okay, so let me just insert a blank slide and let me duplicate this. So let's take a screenshot. Okay, now imagine this is your door and it is basically fixed from here, which you can see this is a fulcrum, right? Pivot. Okay. So now let's say you're opening, this is the door number over here, the D, and you're opening the gate from here, right? And the distance from the pivot, which is perpendicular to the force, is 3 meters. So your D is this. This is your force. Let's apply the formula. So what is the formula of moment? How do we find moment? Moment equals to
M
what?
multiplied by D.
Yeah, it's basically force into perpendicular distance from the pivot, right? So if I just put in the values, I get what? Let's say you were opening your gate from your doorknob and you're applying a force of 5 newtons and your doorknob had a distance of 3 meters from the pivot, right? So your moment is coming out to be that is 15 Newton meter, right? This means that you need this much moment to open your door, right? At least 15 Newton meter to open your door, right? If you're applying a force of 5 newtons, right? Okay. So now let's imagine if I'm trying to open the door from the center, right? Let me insert a blank slide. So now let's imagine the experiment which I told you guys to do is that okay, now try to open the gate from your center, open your door from the center of your door, right? Let's say now you're applying a force here, and the distance which is perpendicular to the force is this, right? This is your D, right? So again, the formula apply करें, you will get the following thing that moment equals to F into D. So now just put in the values. Your force is 5 and your distance from the pivot is 1.5. So gonna get what? Gonna get 7.5 Newton meter, right? That means this moment is not enough to open the door, right? You require at least 15 Newton meter at a force of 5. So now if I say to you guys the following thing, let's say now for let's forget the force is given to you, right? Let's forget this. You don't have the force given, right? That is unknown. If I say now find the force, find the force needed to open the gate, open the door successfully. Okay. And given that it takes a moment of 15 Newton meter open, right? So we want to find F, that is of 3 months. So guys, take out your calculators, take out your copies, pencil, and I'm going to give you 3 minutes to solve this question and get an answer. This would give you the reason why you need to plan more for it. Okay, so let's start. I guess everyone is done. Yes, you can raise down your hands down. Okay, so let's solve it out. It's pretty simple, right? Just to give you a proof, why was it true, right? So let's solve it out. You know, what is given to you. Write down the data, what is given, always. Right? You're given, the moment is 15 Newton meter, right? So now, find the D. What is the D over here? The distance from the pivot.
1.5.
You always need to take the reference from the force to the pivot, right? That is this. That is the distance, right? So your distance is also given, that is 1.5, sorry, meters. So now you want to find what? You want to find F force. So just write down the formula. You have 1 mark for the formula, right? So movement is equals to Ft. Get 1 mark for this. And just now put in the values. 15 equals to F into 1.5. And F equals to basically 15 upon 1.5. Therefore, that gives you answer of F equals to 10 newtons. Okay. So just raise your hand if your answer is matching. So this basically gives you 1 mark, and this answer gives you 1 mark. So you get 3 marks. Yeah, okay, so that's good. Everyone's answer matches. Okay. So I guess now it makes sense. Okay. Now if you try to open the door from the center, so now you will have to apply more force, right? Initially it was 5 newtons. Now you have to apply double force. Okay. Yes, Ruba, question? Okay, okay. So now when I use the idea of movements to now balance a beam, right? So in the last lecture, I told you basically I demonstrated by balancing my pen, right? My stylus. So now I would want you guys to just take a scale or a
सर
pencil.
आपकी वॉइस बहुत कम आ रही है वापस से.
Am I audible? Hello? Am I audible?
Yes,
Yes.
but very little.
Um, uh, is is am I audible clearly to everyone else? If my voice is loud and clear,
Yeah.
give me a thumbs
Yes.
up. If my voice is loud and clear, give me a thumbs up. It is clear to everyone, Hamza. I guess use a headphone or increase the volume
Okay.
of your speaker. Yeah. Okay. So now I would just like you guys to take a scale or a pencil and try balancing it out. Right? Try balancing out your pencil. And if you're done, take a picture and send in the WhatsApp group. Jaldi se. Just take a pencil, or you can open your camera and just show it to me. Okay. Either way, if you can open camera, just show it to me, or just send a picture on the WhatsApp group. Take any instrument, a scale or a pencil, right? Try to balance it on your finger. Take a picture and give it, send it on the WhatsApp group, or you can open your camera and just show it to me. Okay. Whatever suits you. Tell me, I want you guys to basically now do some experiments and then realize, okay, what are we doing? Right? You have 2 minutes to just balance it out, take a snap, or just open the camera to show it to me. Right? I'm waiting on the WhatsApp chat.
Sir, what? What do we have to do?
Yes, Hamza?
What do we have to do?
I'm just saying, okay, just take a pencil or a scale, try to balance the pencil or a scale on your finger, right? Okay, if you're able to balance it, you can say successfully, just send a picture on the WhatsApp group, or you can open the camera and just show it to me. Okay, I got the picture from Ruba. Ruba is able to balance the pen, and I got the snap over here, and also over here, Mashal also, right? Okay, okay. So Hamza जल्दी के भेजना रो. Okay, so now just try to think. Okay,
हो ही नहीं रहा, क्या करूं?
yes,
हो ही नहीं रहा बैलेंस.
correct. So now let's see. Okay, this is your finger, right? Let's see. This is the paper, right? Whatever object you have, let me just create the object using this, right? Okay, this is the object, right? So it had certain mass over here, right? Has certain mass over here, that is M1. It has certain mass over here, right? Let's say M2, right? You can assume this, okay, this mass is centered over here, right? Let's say I'm just going to assume a single point, right? जहाँ पे आपका mass sort of the entire mass of the sphere is acting, right? So one force should be acting over here. Let's say if you're trying to balance out your object, it would flip sometimes over here. And let's say if you move your pivot position, it would move sometimes over here, right? Because these are forces over here. And this is the pivot center that was your finger, right? And this is the distance D1. And this is the distance D2, right? So you found a point that basically balanced out what? Some movements over here, right? So if this object moves in this direction, so this is called clockwise movement, right? If you see the clock moves in this direction, right? So this is called clockwise movement. And if your object is moving in this direction, so it is basically anti-clockwise movement. Right? So now we can combine movements to basically have an idea of how is it useful, right? It has a very practical application in, you can say, in industry, right? If you see, okay, if you see, have you seen? Let me just show to you afterwards. Okay, afterwards. So this is basically balancing a beam idea over here. So you all did experiment जिसके अंदर आप लोगों ने let's say you took a ruler, ठीक है, and you balance out your pen वगैरह. Okay. So now let's imagine this, right? Imagine this over here. Okay. So now हमने scale को basically center से fix कर दिया है. This is the fixed point over here, pivot, right? Taking the same idea which you had done in your basically picture. This is fixed over here. So this is a pivot, right? So object can either move in this direction, the scale, or in this direction, right? So now I'm going to place the masses in such a way that it is in equilibrium. It is not moving, it is balanced out. So now I will have two masses. Okay? One will produce basically anti-clockwise moment, right? One will produce clockwise moment in this direction, right? Okay. So now let me just find the clockwise moment, right? So I have mass 2. It would have weight 2, right? Some certain weight. So weight is equivalent to a force, right? We have seen that. And mass 1 would have certain weight also. Okay. That is going to be this. I'm going to call it weight 1, right? And you can see the distance which is perpendicular to the pivot is d1 for mass 1 and d2 for mass 2, right? So can anyone tell me how do I find moment in clockwise direction? I know the moment is equals to fd, right? What would be the formula of moment in clockwise direction? Which weight is causing the clockwise moment?
Gravity.
Nah. Which weight component is causing the clockwise movement? W1 or W2,
W2.
right? This is causing the object to move in clockwise direction, right? So I'm going to take this particular force right now. So we're going to do W2, that is the force that is causing the clockwise movement, times the distance of this force from the pivot. That is distance to it. So therefore, you have the clockwise moment to be W2, D2, right? So now what about the movements in anti-clockwise direction? Which weight is causing the anti-clockwise motion movements? Which is
W1
W1, right?
into D1.
Yeah, right. So this is basically which you want to recognize. So it's going to be W1 into D1. Therefore, the moment which is causing anti-clockwise movement is going to be W1 D1, right? Now, what is the condition which we want to fulfill? That is, I want to balance out the scale, right? I want the scale to be balanced in equilibrium, right? So for that, we have principle of moments, right? So what is principle of moments? So this is basically states when a body is an object and when a body or object is in equilibrium, right? So what is important? The sum of clockwise movement about a point is equals to the sum of anti-clockwise movement about the same point, right? So there is no resultant moment which will cause the object to move. So the object will basically be stationary, and you can see the scale would be like this, which is going to be horizontal over here, right? Okay. So another way of saying this is all if you add the moments, it will basically add up to zero, right? Because a moment is basically in this direction, right? A moment is basically causing in this direction, right? So they're opposite to each other, right? Right? Does that make sense? So it will add up to zero. Okay. So now what was the experiment before? हमने basically we found these points D1 and D2 experimentally. ठीक है? वो कैसे किया था हम लोगों ने? So let's take this example over here. So to balance a beam about a pivot like the ruler figure this which is shown over here, the weights must be moved so that the clockwise turning effect equals the anti-clockwise turning effect, right? Which we have seen, right? So that the net movement becomes zero, right? What is the net movement? K. Let's take clockwise as positive and anti-clockwise as negative, right? So if you add, let's say plus 2 minus 2. So let's say plus 2 is the clockwise movement and minus 2 is your anti-clockwise movement. So net movement जो overall system पे apply हो रहा है would be zero, right? So now they're saying कि how do we balance out if the beam, which basically when you were balancing out your pen or a scale, so you basically did this part, right? If the beam tends to swing clockwise, M1 can be moved further, right? Let's say if it is moving, let's say in this direction, clockwise. So they are saying that you want to adjust the position of M2, M1, okay, to make it further apart, right? So it increases the turning effect, okay, because movement is equals to what? Movement equals to force into distance. And from the formula, you can see that movement is directly proportional to distance, right? So if you increase the distance of M1, it will increase the anti-clockwise movement because it was swinging in clockwise direction, right? It means that clockwise का movement ज़्यादा है compared to anti-clockwise. So you want to increase anti-clockwise movement so that you can increase it by increasing the distance, right? D1. So that is some trial and error method. And similarly, you can do arrange for M2 if it is moving for anti-clockwise. So you have done the experiment, you have learned how to balance out a pen or a scale. I guess Hamza se nahi hua. Hamza, you can try this after the class. You will find a point here, it will balance out, right? Yes,
Okay.
Hamza. Okay, no questions. So now, acha, if I write this formula down mathematically, what does that mean? It means case sum of and clockwise moment is equals to sum of anti-clockwise moment. Okay, so this symbol means sum of, and M subscript CW means moments, moment in clockwise direction, clockwise direction, and moment anti-clockwise means moment in anti-clockwise direction. Okay, so if this formula is clear, kindly give me a thumbs up. Principal moments. We'll do example which will make sense, right? Okay, it is clear to everyone. That's good. That's good. Okay. So now you have a question. So I want you guys to start solving this out. I'm just writing down the formula. So I'm gonna give you 4 minutes for this, okay? Since it is new to you. So that is moment of clockwise is equals to sum of moment of anti-clockwise, right? So now I want you guys to find the value of basically W, right? They're saying that the seesaw is now equilibrium, right? It is basically in balance position. It is equilibrium, right? So you can only apply this formula if it is in equilibrium, right? So now try to solve it out. And if you're done, raise your hand, okay? Okay, guys, I believe that everyone is done. Let's start solving this question, right? So it is a pretty important question which will help you solving your theoretical questions, right? And even MCQs. Okay. So let's start it out, right? So what is the first step which you should start with, right? That is the following. The first step is going to basically identify clockwise and anti-clockwise moment. Okay? That which component of forces are causing clockwise moment and which component of forces are causing anti-clockwise moment, right? And then you just want to apply. You want to apply what? The principle of moment. Right? That's it, right? These are the two easy steps over here. Okay, so this is the algorithm which you want to apply. So now let's see what components of forces are causing clockwise and what component of forces are causing anti-clockwise movement, right? So now let's mark it out over here. So you can see this is the pivot over here, right? So this component of force will cause the object, the lever to oscillate in this direction, right? So just imagine this, this is clockwise motion, right? And this is anti-clockwise motion, right? Let's see your watch or clock and see how is the clock pen moving, right? Pendulum moving. So it's moving in clockwise direction. That is why it is called clockwise, right? And even this 320 force is also going to cause the lever to move in anti-clockwise motion, right? So this is causing anti-clockwise motion. This is causing anti-clockwise motion, right? And this W weight is going to cause the motion of the lever in this direction, right? That is going to be clockwise, right? Now you identify the components. Now just simply apply this formula, right? This principle of moment formula. So now what is the formula says? It says sum of moments in clockwise direction is equals to sum of moments in anti-clockwise direction about the same point. What is the meaning of about the same point? It means your pivot is same, right? So for this scenario, pivot is basically same, right? It is same. So for you're gonna find now the distances, right? For every couple of forces. So for 540 Newton, the distance which is perpendicular for 540 is this one, right? Which is given to you, which is 1, right? It is forming an angle of 90 degrees. And for a force of 320 newtons, what is the distance which we will take? That is going to be this, right? From the force till the pivot. That is given to you as 3 meters, right? Okay. Similarly, for weight W, Now I take the distance that is going to be from the force till the pivot. That is going to be again 3 meters, right? Now you have everything. Just want to put it into the formula and get your answer, right? So you have only one clockwise movement vector, right? Which is only W. Only W is causing the movements in clockwise direction. The other two forces are causing the movements in anti-clockwise motion. Okay. So let's put in the formula. So therefore, we get the following that W into 3 equals to, right? So there is no other any clockwise moment creation over here. So we have just one component over here, right? Now we have one 540 and then 320 Newton, which is causing the anti-clockwise movement. So I'm gonna take this component, right? So 540 times 1, right, is going to produce an anti-clockwise motion. Plus, what else moment is there, right? You also have 320 Newton component, right, which is causing the anti-clockwise motion. And the distance is 3 meters, right? So let's do this. You are summing up all of the basically moments, right, in anti-clockwise motion. 320 times 3, right? So this is the equation. Just want to simplify it. So it's going to be 3W, going to be 540 plus 320 times 3 is 960. And what is 960 plus 540? 14. It's 1500, right? And W equals to what? 1500 divided by 3. That is going to be 500, right? So your W force should be at least, but exactly 500 newtons to basically balance out your balance out the lever, right? So that is your answer, right? If your answers were matching with my answer, kindly give me a thumbs up. Okay, Masha's answer was matching, Vaza's answer was matching, and Ryan also, Rupa also, Hamza also, Rupa also. That's good. That's good. That's good. Okay. So I believe now you know the principle. Okay. So let me just give you one more question, right? Abhi, this is easy. Let me give you one more question to solve. Like you have a good practice, right? So now do this question, right? Practice question. Practice question. Okay. Hmm. Now you have pivot, right? And you have a lever, right? This is the center of the pivot. Let's imagine it's the center, right? So you have mass 1 here. You have mass 2 here. You have mass 3 over here. You have mass 4. And you have mass 5 here. Okay? Okay. Now this M5 became messy. This is mass 5, right? And let me just give you the readings. This is the center of the masses. This is the center of the masses. Center of the mass. Okay, so at this point, this let's imagine this is a ruler scale, right? This is a ruler scale. Okay, so now I'm just giving you values over here. This is 10 centimeter. This is 30. This is 40. This is 60. This is 70. This is 98. So you're given the weights, right? You're given the masses. M1 is basically equals to M2, that is equals to 5 kg. And you're given M3 equals to M4, that is equals to 3 kg. Right? Now you want to find M5 such that the scale is in equilibrium. right? It's a 6 mark question. So now I'm gonna give you a formula that sum of movement in clockwise direction equals to sum of moments in anti-clockwise direction. ठीक है जल्दी से करेंगे you have 4 minutes for this. It's pretty simple. You have the values of the distances, you have the values of their weights, you know the masses, you can find weights. We want to find the mass 5 such that the scale is in equilibrium, right? I don't know the mass 5. I can put any value of mass 5 just to basically gain equilibrium. Okay, so now let's find the distance, right? So the distance for mass 2 from the pivot is going to be 40 minus 30, that is going to be 10, right? It's in centimeters, right? So we want to convert it into meters. So this is going to be what? So this is 10 centimeter, right? Similarly, from here till here, this would be 40 minus 10, right? So 30 centimeter. And this is, let's say, D1. This is D2. Let's find D3. So what is the distance of the D mass 3 from the pivot? That is going to be 60 minus 40. So D3 is basically 20 centimeter. Right? Now your D4 is going to be 70 minus 40. That is going to be 30 centimeter. And the distance of the mass 4 from the pivot is going to be D4. That is 90 minus 40. That is 50 centimeter, right? Okay. So you now have all the values you know what is the formula of weight. Okay. The weight is going to be mg and you can take g as 10, right? Or 9/81 depending upon your requirements. You want to take 10, right? So your weight is going to be what? It's going to be just 10 m, right? Just multiply the value of gravity with the mass. That is 10 m, right? So now I'm going to create the equation, right? Let's create the equation. So what is the equation? That sum of clockwise moment is equals to sum of anti-clockwise moment, right? Okay, before that
मेरा
I'm
वो
going to
क्वेश्चन ऐसे तो नहीं गया था, मेरा गलत है, मुझे समझ नहीं आ रहा है क्वेश्चन.
क्या हमजा क्या बोल रहा हूँ? Okay, I'm just solving it out over here. Let's I guess it makes sense, right? Okay, so let's convert the readings into meter, right? So how do you convert from meter centimeter to meter, right? You know, okay, 1 meter is 100 centimeter, right? And if you go from centimeter to meter, you divide by 100, right? So that is equivalent to 0.3 meters, and this is equivalent to 0.1 meter, right? In order to highlight this using the highlighter, right? And this is equivalent to 0.2 meters. This is equivalent to 0.3 meters, and this is equivalent to 0.5 meters, right? Highlighting the values in meters. Okay, so now let's apply the formula. So what is the factor that is causing anti-clockwise moment? That is basically this. Weight 1 is causing and weight 2 is causing anti-clockwise moment, right? So the blue shows anti-clockwise, right? And let's say the green shows clockwise, right? Okay, so now this weight 3 is going to cause clockwise moment, this weight 4 is going to cause clockwise moment, and this weight 5 is also going to cause clockwise movement, right? So you have identified all of these movements direction, right? So now let's add on the equation over here, right? Okay, so let's add on the equation. Let me just save this out ताकि we can keep track of the progress. Okay, so clockwise क्या हमारे पास? It is weight 3, 4, 5, right? So going to be W3 into D3 plus W4 into D4 plus W5 into D5, right? equals to which weights are causing anti-clockwise motion? That is W1 and W2, right? So it's going to be W1 T1 plus W2 D2. Now let's put in the values and let's see what do we get. So M3 and 4 are 3. So you can find the weight by basically multiplying the mass with gravitational force. Rating gravitational force is 10, right? So it's going to be as follows. So it's W3 क्या होगा मेरे पास? W3 is going to be, let me just work out over here. We'll work out the value of weights over here.
सर मास कहाँ से पता चलेगा?
अब तो मैंने मास दिया हुआ है ना? ये क्या दिया आपने? This is the mass given to you, right?
अच्छा.
That was the question, no? Okay. So now let's find W3. What will be W3 is going to be mass 3 times 10, right? And mass 3 क्या थी हमारे पास? It was 3. Sorry, हाँ 3 था. So it's going to be 10 is on bucks. Sorry. It's going to be 30 newtons, right? So since mass हमारे पास 4 भी 3 kg है, so mass 4 का जो weight होगा वो भी 30 न्यूटन होगा, right? So you will also have W4 equals to 30 newtons. Okay. So now let's find W1 equals to W2, right? जो हम निकाल चुके हैं पहले से. ठीक है, जब निकालेंगे भी उसका बेसिकली वेट इज 5. सो दोनों की मासेस सेम है, दोनों का वेट भी सेम है. 5 into 10 is going to give you 15 minutes, right? So you get the following things now. Okay, so W3 आपको पता है that is 30. And what is the distance 3? What is distance 3 over here? That is this. ठीक है, 0.2 times 0.2 plus W4. What is W4? W4 is same as W3, that is 30. And what is the distance 4 over here? Distance 4 कितना है हमारे पास? It is 0.3 meter, right? ठीक है, let's keep W5 as W5. Yeah, no, हमारे ठीक है. What is distance 5 कितना है हमारे पास? It is 0.5 meter, right? So times 0.5 equals to, what is W1? हम निकाल चुके हैं यहाँ पे 50 newtons, right? 50 times distance हमारा कितना है हमारे पास? What is D1? The D1 is 0.3 meter, right? Over here. This is times 0.3 plus weight 2 is also same as weight 1, that 50. What is distance 2? That is 0.1 meter, right? So let's simplify this. So what is 30 times 0.2? Can anyone tell me the answer? I don't have the calculator. So it's going to be 0.3 into 2. 0.6? No, it's going to be 6. It's going to be 2 upon 100. 2 upon 10 is going to be 6, right? 6 plus 3 upon 10 are going to be 9.
9.
Yeah, plus 0.5 W5 equals to, what is 50 upon 0.3? 15, right? Plus 5. So you get what? What is 9 plus 6? 15, right? Plus 0.5 W5 equals to 20, right? So 0.5 W5 equals to 20 minus 15, right? So let me add another slide. So you get 0.5 W5 equals to 5, right? So now let's get the value of weight 5 of the mass 5. That is going to be 5 times 2, right? Because what is 0.5? 0.5 is 1 upon 2, right? So 2 multiply whatever. So W5 is coming out to be 10 newtons, right? आपको निकालने क्या है? You want to find the mass of it, right? You know okay, what is the formula of weight? Weight equals to, ठीक है, mass 5 times gravity, and we're taking gravity value as 10 meter per second square. So your mass 5 is going to be the weight 5 divided by the gravitational strength. It is going to be 10 upon 10. So your mass 5 will convert to be 1 kilogram. Does that make sense?
सर लेकिन मेरे सिलेबस में ग्रेविटेशनल ये ग्रेविटी जो है ये 9.8 है.
हाँ, you can take 9.81. तो उससे आपके पास आंसर थोड़ा 1.1 आ जाएगा क्वेश्चन से. So can you explain what is a lever? Just go to the Greek time and people lifting heavy stones from their bare bodies. Can you explain how lever would be helpful in that time?
Sir, they can attach a lever to like a mechanism that would lift up the rocks or the materials they needed.
Yeah. And how would it help it out?
Sir, like lever को हम turn करते like उसको flip कर सकते हैं ना. It's kind of like a switch, I guess.
So benefit
So
क्या है? I know कि I can lift up basically stones वगैरह, but I still need to apply force, right? Is there any benefit of using a lever instead of just picking it up with my bare hands?
Yes, sir, it makes it easier to pick up the heavy objects.
Yeah, ठीक है. So yeah, that is good. So imagine कि you have, okay, my pen is not working. एक minute. Let me restart my PowerPoint. Yeah, as both of you guys said, कि yes, sir, it makes it easier to pick up objects, right? So benefit is that कि you will have to apply less force to pick up the huge stone, right? Imagine कि the stone weight is, let's say, 5,000 newtons. By using a lever, you only need to apply, let's say, 100 newtons, right? So you can use the principle of moments का idea to basically pick up heavy objects. So we'll see that in a while कि how is it useful. Let me just fix my touchpad. Okay, so now let's go there. Let's move down. Okay, not too down. Yeah, over here. Okay. So now let's see what benefit do we have of using a lever, right? So imagine okay, you have this particular stone, right? This is the ground over here, and you want to pick up this stone, right? Let's say this is Masha standing over here. She wants to pick up this huge stone, right? And let's say the weight of this stone is, let's say, 5,000 newtons, right? Imagine she uses a pivot over here, right? And she fixes a lever, right? She fixes a lever over here, and she's going to apply a force on this lever, right? In this direction. Okay. And let's say she only needs a force of 100 Newton, right? So depending upon the distance, right, from here, that is D2, and let's say distance from here till here, that is D1. So imagine if my distance is greater, so my moments are balanced out, right? So because moment formula is force into distance, right? So if I increase my distance, ठीक है जी, if I increase my distance, my moment will also increase, right? So now, depending upon this, I can have less amount of force to apply to pick up a huge stone, right? So that are called levers. So these are called levers, right? So a lever may be a device which can turn about a pivot, which we have seen right down in this example, right? So in a working lever, a force called effort is used to overcome a resisting force called the load, right? So this is the load over here of the stone, and this is the effort, right? So you're applying this effort to basically pick up or roll over the stone, right? So the pivotal point is called fulcrum. Okay, so the pivot which we have placed over here is called fulcrum over here, right? So this is called fulcrum or pivot. ठीक है जी, it's just used to basically provide a point where you can basically apply moment formula, right? You apply principle of moments. So if you use a crowbar to move heavy objects, ठीक है, our hands apply the effort at one end of the bar, and the load of the force basically exerts a force on the other end, right? So which we have seen over here. You can also see this. This is a good, you can say, diagram to just visualize. You can see this is the distance from your fulcrum to your effort, right? Let's say you are applying a force here. Let's say you have a rope and you are stretching the rope from here, right? And this is, let's say, Masha is standing over here, right? So she's applying the force from here, and and this is the distance, let's say distance OB, right? And this is the distance OA, right? And here is the load weight over here, that is, let's say W, which is applying a certain load component force over here. This is the fulcrum which we have seen also in the last diagram. So imagine this, just see this, right? Distance OB is way huge than distance OA, right? So since I told you guys the moment formula depends upon what? Force times distance, right? So let's say you have, let's imagine this is 5,000 newtons and this is, let's say, 10 centimeter, right? So 10 centimeter is 0.1 meters and 200 centimeter is 2 meters, right? So let's find out the force required, right? Let's find the moment over here, right? Let's find this moment over here. What is moment of load? Distance OA is 0.1 meter and distance OB is 2 meters, right? So let's find the moment from the load, right? So moment of load is going to be 5,000 times 0.1. So what is the moment coming out to be? It's 500 Newton meter, right? Similarly, let's figure out what effort do we need to basically counteract this, right? So I want to lift, I want to at least provide a moment around this particular point that is equal and greater than this, right? So let me insert a blank slide. So you know, okay, what is moment OB going to be? That is going to be 500 Newton meter, right? We know the distance from the fulcrum to the B, that is distance OB, that is 2 meters, right? So distance OB is 2 meters. So let's find the effort, right? Let's find the force of the effort that is put by Mashal, right? So again, you know what is the formula of moment? That is going to be a moment, I'm finding moment of, let's say, effort, right? That is going to be moment of OB. I want to pick up this much load, right? That is going to be force of effort times distance OB, right? So this is 500 and this is equals to F into F effort times 2, right? Let's find the force that you need to apply to pick up the stone, right? That is going to be 250 newtons. Okay, so that's way small, right? Imagine you want to pick up 5,000 Newton weight and only apply a force of 250 Newton to basically pick it up. Does that make sense? The benefit of levers and moments. If it makes sense, give me a thumbs up.
Sir, can you explain this once again?
Okay. So who got this? जिसको समझ आ गया, just give me a thumbs up. हमजा को clear है, वर्दा को clear है. What about Ryan and Maeve? Okay, I guess they both are chilling out. Okay. So कहाँ पे you are lost, Ruba? There were you lost?
Sir, when you found the effort.
This part?
Yes, this one.
Okay, let me just repeat for all of you. I believe he may also need a repetition. So you know, okay, what is this configuration, right? So you have a F stone over here and it is exerting a force of W, right? Which is 5,000 newtons in this direction, right? And you would have to apply effort in this direction to basically pick it up or let's say roll it over, right? So this is the fulcrum which we have fixed, around which we are applying principle of moment, right? Make sense? Okay.
Yes.
So now आपको distance OA दिया हुआ है, that is 0.1 meters, right? And you have distance OB from the pivot till the point where the force is applied, and it is perpendicular, right? It's perpendicular. So distance OB is 2 meters. Okay. So I know this 5,000 Newton W. I know the distance OA. So I found out okay, what is the moment from the load, right? That is in anti-clockwise direction.
Yes.
So I found this out. So I need to at least apply this much moment around this basically in clockwise direction to basically at least reach a point that I can move the load, right? Make sense?
Yes.
So I want to see, I know okay, my effort should be at least 500 Newton. That is equal to the load, right? Because I need to at least reach 500 Newton meter to start moving it basically or roll it over, right?
Yes.
This is the formula which basically comes out. So moment of effort which I need to apply should be at least be equal to moment that is basically provided by the load, right? That is 500. So then again, you know formula of moment. So moment is simply force into distance, right? So यहाँ पे force is the effort जो हम apply कर रहे हैं, which is applied by Mashal, which is standing over here, right? So
Yes.
and distance, you know the distance from the pivot at from the effort, okay? That is basically this DOB, right? That is 2. So just you just put in the values. So this is the movement which you require. This is distance in meters, and this is unknown, right? So you can just simply make F effort subject, and the answer comes out to be 250 Newton, right?
Yes, yes.
Okay. So this is the force which you at least need to start rolling the stone or start picking the stone, right? Just compare 5,000 Newton that was applied by the, let's say, the weight of the stone, and you just need 250 Newton to basically move it over. That is the benefit of levers. Now, does that make sense? Give me a thumbs up if it makes sense. Okay, good. Okay, good, perfect. Okay. So this is how the Greeks picked up huge stones in their time and they made the pyramids which are found in Egypt right now. Okay. This, if you have seen it, the pyramids of Egypt, basically physically or through videos, they are huge stones, right? They are huge stones. So people used to first of all pick them up with bare hands, and they used to use elephants वगैरह to drag them. But they've invented this particular phenomena which made the lifting and the movement easier, right? So they just used to lift the stone and place them on the carts. So also at that time, wheels were also invented, right? We were able to invent wheels, right? Using stones. So we then used to use elephants to basically drag them around, right? So let's say this is your carriage, and this is the huge elephant over here. Imagine this is an elephant, right? This is an elephant, and they used to just use the lever to basically place it over here, right? And then they used to move around this particular pyramid, let's say stone, to the desired position. Okay. So again, a lot of things were found in Greek times. Okay, wheels, carts, okay, and levers. Okay, and they also found the distance from the sun to the earth. Okay, using some methods which you will see in your future lessons of physics. Okay. So again, levers is also this. You might have seen this in let's say in areas where there's construction, or let's say if someone is moving around some stones or some weight. Let's say if you usually they are found in constructions. So you can see, okay, the load is over here, right? This is the load over here. Let's say this is sand which needs to go to a construction site. This is the fulcrum, right? Because everything is balanced over here when the driver or let's say a person is moving this carriage, right? They hold this up and they basically balance everything on this fulcrum, right? So you can see here the load is at this particular side. This is let's say center of this particular mass of this particular load, and this you want to apply basically effort upwards, right? Because obviously it is moving down due to the weight. You want to apply a anti-clockwise basically effort to basically lift it up from the ground and then start moving it out, right? So again, we invented wheels and movement of material from one point to others became easy, right? So it is an application of levers. Imagine working out, right? So you might be working out your biceps, or just simply you are just basically pumping up your biceps. So what is happening over here? How does your biceps basically get pumped? That is due to again lever mechanism. When you lift weights, your weight basically has a component in vertical downwards. That is the weight of the weights, okay, or the load, and your muscles are basically providing you effort in this particular direction, which basically cause a pump in your muscles, and you basically get revved if you keep on doing this exercise or workouts and daily routines, okay. So again, one of the application of levers, okay. This is pretty simple, right? And you can see the load is this, the center of this particular scissor is this, and it has a component in this direction. Again, everything is balanced on this, we can say fulcrum. And then you apply forces with the fingers in this direction to provide a counter force to again move it in the opposite direction. Yes.
Sir, fulcrum is basically the pivot, right?
Yeah, pivot around which it is centered.
Okay.
right? Which is holding everything together. Okay. Then you have conditions for equilibrium, right? So equilibrium may we have seen okay, you should have sum of forces should be zero, right? Let's say if you have this, which was your homework, right? Let's say this was your weight of the rod or the lever, and this was, let's say, P, this was Q, right? So let's say this is balanced right now. So your P plus Q is equals to 600. That is why it is balanced. You can see okay, this force is downwards, the 600 Newton is downward, and P and Q are basically trying to balance it out, right? Because this pivot is exerting a force upwards, that is P, and this pivot, that is pivot 2, is exerting a force that is upward Q. So P plus Q is providing opposing forces to balance out 600 Newton, right? So this equation can be used in your homework, right? So you can use now this equation, okay, for this question. Okay, so then the law of movement must apply. That is, imagine if we have a pivot over here, and if we have, let's say a pivot, let's say something mass one over here, and you have a set of moments over here. This is, let's say, producing anti-clockwise moment, okay, and this is producing clockwise moment, right? So your moment anti-clockwise, sum of anti-clockwise moment should be equal to sum of clockwise moment. Okay, that means they should be equal. So if you subtract moments, anti-clockwise moment from clockwise moments, you should get zero. Okay, so there should be no resultant force and there should be no resultant moment also. Okay, if just imagine if the object is having no rotational motion, okay, either in this direction or in this direction, and the object is not moving upwards or downwards, that means it has zero resultant force. Okay, this scenario means it has zero resultant force. It is not accelerating, and this means if it is not it is either not rotating in clockwise direction or anti-clockwise direction. It means it has zero resultant moment. Yes, Ruba.
Sir, I would be leaving now because I have another class. So
Okay.
I'll watch the recordings for the rest of the
Sure.
class.
Sure. Sure.
Okay?
Okay. Okay. Love it. Okay. So if it is clear till now, raise your hands or give me a thumbs up. Not raise your hands. Okay. Good. Okay, so now you had to use this condition to just solve this question, right? I hope it will make sense now. Okay. So now we have center of gravity. Can you explain what is center of gravity?
सर एक पॉइंट ऑफ द बॉडी जहाँ और पूरी फोर्स लग रही है.
Okay. Anyone else? Good. Anyone else want to explain center of gravity? Yes.
Sir, we can say that it's the point where all the gravity is like concentrated.
Good. Good. So from concentrated point of view, what other phenomena comes into your head?
Mass.
Good. Good. So yeah, you know that K weight is equals to mg, right? Okay. So if I'm talking about center of gravity, right? So it should also be linked to center of mass, right? Okay, it should have a connection of with center of mass, right? Okay. So now let's define the definitions of both of them, right? So let's define center of gravity first, and then let's define center of mass, right? And let's see okay, how are they different and how are they same, right? So what is center of gravity? As Ryan said, it is a point. It is the point at which the weight of an object appears to act. Does that make sense? Right? So if I have, let's say, if I have a point mass like this, so iska center would be a point where you basically be drawing your center of gravity, right? So you would have a vector of weight from the center of gravity, center of circle from here, and you will show it by W. Okay, so this is your center of gravity. So it is the point at which the weight of an object appears to act, right? So you are assuming that we have masses also over here, also, over here also, but we usually for simplicity we take K it is the for geometric objects, let's say for circles, for squares, for rectangles, your geometric center is the point of center of gravity. Does that make sense? Okay. So let's find some center of gravity for regular objects, right? For regular objects, for regular shapes. Okay. Let's start with a rectangle. So where is the center of gravity?
Sir, in the middle.
Right. So how do you find it out experimentally?
सर वो एक लैम्डा होता है ना एक इसमें लाइक एक पिन होती है और उस पे थ्रेड लगा हुआ होता है
नहीं, that
और
regular objects. For regular,
ओके
you just draw diagonal lines, and when the diagonal lines are basically intersecting, that is your center of gravity, right? For regular objects, this is your center of gravity. Does that make sense? Does it make sense? Give me a thumbs up if it makes sense. For rectangles. Okay, good. So let me just now do for different shapes. ताकि it makes sense to you guys. कि how do you find it, right? It comes in your MCQs theory. So let me just do it once. So now let's do it for a square, right? Right. Again, you will draw two diagonal lines, right, touching the corners, and the point where they are touching is basically your center of gravity. Okay. So now let's draw it for a circle. एक मिनट रुके. Okay. So again, इसमें you just need to draw two diameter lines, right? This is one diameter, this is another diameter, and this is the point where you basically will have your center of gravity. Okay. So similarly, you can find it for triangles also. ठीक है जी? For triangles. Okay. So again, you draw a line of symmetries over here. And so this is your center of gravity, right? Does that make sense? How do you find center of gravities of regular objects? Okay. Quickly give me a thumbs up. Okay, I can just take your feedbacks. Okay. Maeve, is it not clear?
No, I understood it.
Which part is not clear?
No, I understood it.
Okay, you understood it. Okay. Good. So now if I talk about irregular objects, if I talk about irregular objects, so what have I drawn over here? Irregular objects. So have you done this experiment? Do you recall this experiment of Lamina?
yes
So for irregular objects, if you want to find center of gravity, okay, so we will just do it with the experiment of center of mass, right? So let imagine if you have irregular object like this, right? How would you find its center of gravity and center of mass? Okay, so how would you find center of gravity and center of mass? Right. So before that, I'm going to just give you a definition of center of mass. Okay. So let's discuss it out. What is center of mass? So what is center of mass? Can you explain? What would be center of mass of an object? Yes, anyone daring enough to take the lead and answer. Yes, Vardha.
सर एक पॉइंट पे जहाँ पूरी मास कंसंट्रेट होती है या पूरी मास लाइक ज्यादा होती है.
So is it same as center of gravity?
नहीं, क्योंकि वो सेंटर ऑफ ग्रेविटी एक पॉइंट पे अफेक्ट होती है.
Okay, ठीक है. Anyone else?
Sir,
Yes.
the center of gravity is a pull, and the center of mass is like mass.
Perfect. Perfect. Okay, जी. Good. ठीक है जी. That's good. So let's write it out formally. So it is a point. Right? It is a point where all of the mass of an object is concentrated, right? So just imagine basically be sure to use correct terminologies in your answer, right? क्या लिख दिया मैंने? Is concentrated, right? This is very important. Where all of the mass of an object is concentrated, right? So it's pretty similar to center of gravity, but it is basically saying okay, where all of the mass of an object is concentrated. Like imagine okay, if we just talk about regular objects, right? Let me just draw regular shapes. Okay, how do we find center of mass for regular shapes? It's pretty similar to center of gravity. Right? So let me just draw shapes. Let's imagine if we have a rectangle. Okay. Okay, into shape tuning of it. Let me just do it again. If we just talk about this. Good. Okay. So if I make a rectangle over here, you can see here, if I want to find center of mass, again I will draw diagonal lines. Right? So now again, this is also the center of mass, right? I will not draw any vector. This is also a point where the entire mass of an object is concentrated, right? So imagine the formula, right? Weight equals to mg, right? So you can just see कि mass and weight are tightly proportional to each other, right? So you can see कि यहाँ पे weight भी add कर रहा है and यहाँ पे सारी mass is also concentrated over here, right? So for simplicity, physicists assume a single point of a body where the entire mass is concentrated just to make calculations simpler. Otherwise, you would have weight vector over here also, some weight over here also, some weight over here also. This would mess up your calculations and it make calculation pretty complex. So for simplicity, we only take center of mass and center of gravity points to assume that the entire weight of an object of a regular shape is acting at the same point, right? So for regular shapes, center of mass and weight हमारे पास same point पे होता है. Does that make sense? So if I just draw a square also, okay, so let's say this is a square and this is length by length. Again, if I draw diagonal lines, right? So this is also the point center of mass, right? Okay, so now let me just draw for the last example a circle. Okay, you can draw diameter lines over here. Okay, I need to diameter lines. Okay, this is not good. Let me just draw it correctly. I need to diameter lines like this. Right, so this will be the basic center of mass over here. Okay, this my drawing is not good. This is the center of mass of regular objects, right? So now we are talking about irregular shapes, right? So now let's see कि how do we find center of mass and center of gravity for irregular shapes. The meeting is about to end. Kindly rejoin everyone. ठीक है, let's not waste time. So now is it clear till now? How do we find center of mass and center of gravity of regular objects? If it is clear, give me a thumbs up. Quickly give me a thumbs up. Ryan, Not clear? Okay, so now let's quickly let's see what is the content which was written in the slide, ताकि we can just progress forward. So center of gravity is defined as follows, which we have done in your last class. I told you guys to balance your scales, right, or a pen. So you basically place your finger in such a way that it was balanced, right? So for a regular scale, the center value would be 50, right? So if you put a support over here, your scale will balance out. Similarly, just imagine your finger over here, right? You were using your finger as a lever, right? As a pivot, right? Which basically made you find the center point, right? The center of mass. Okay. So your weight of a regular scale is basically at the center. You also found out, okay, if you recall your experiments, we have pictures of those, right? You can open them and you can see, okay, it was approximately the center of the scale. Okay. So when you point, let's imagine if your finger is over here, the scale would be basically toppling over here, right? In clockwise direction. Okay. So what is written over here? An object behaves as if its whole mass were concentrated at one point, right? That is called the center of gravity, right? The object's weight can be considered at this particular point. So for your easiness, for your convenience, we assume a single point at which the entire weight of a body is acting, right? And for center of gravity of a uniform scale, uniform ruler means कि it has uniform mass, right? So यहाँ पे जो mass है, let's say the mass one at the left and mass two at the right is uniformly distributed, right? ऐसा नहीं है कि यहाँ से scale thick है, यहाँ से scale basically is thinner over here, which basically distributes the mass unevenly. We're assuming that the scale has uniform mass distribution, right? So then we can simply say that the center of the scale is the point where it can be balanced, right? I hope it makes sense, right? If you have question, please raise your hand. And then we have this defined center of gravity, and we have found the center of gravity of regular shapes. We'll find that how do we find for irregular shapes in a while. And we had defined center of mass. Center of mass is linked with the center of with weight also. Therefore, for regular shapes, we can say कि जहाँ पे center of mass होगा, वहीं पे center of weight भी होगा हमारे पास, right? Center of gravity. Okay, so now let's start with the non-uniform shapes, right? Let's start with the non-uniform shapes. ठीक है जी इसके अंदर we'll find both. We'll find center of gravity. I find also center of mass. Okay. So this experiment is called the lamina experiment, right? The lamina experiment. Okay, so in this, what do we have? We have the following setup. So we have a retort stand, right? We have a retort stand. Okay, and then we have a thread, right? And we have a ball bearing, right? Which is a metal ball bearing. Let me just make it with red. Right, so we have a thread and we have a ball bearing. Just to basically keep the thread straight, right? And then we also have the laminate. We have the lamina. So let me just write down the steps for the experiment. Then we will explain it using diagrams, right? So what are the steps of this to perform the experiment? So imagine you have your lamina like this, right? Imagine you take 2 points, 3 points, right? A, B, C. What is the step number one? It is as follows. Okay. You make holes. This is your laminate. The lamina is called a sheet, right? It's just a sheet, irregular shaped sheet. So you want to make holes at the edges of your lamina, right? Such that they are not at the boundaries, right? They are not at the boundaries. Right? Imagine if you make a hole here, okay? So this, let's say if you hang your lamina on your retort stand, so this would break out. This would basically break out your lamina, right? So you want to make sure that they are at the at the edges, but not close to the boundary, such that your lamina does not tear off, right? Okay, so you want to make sure this thing, okay, it is not at the boundary. Okay. And the second step is you will do what? You will basically hang this up. You will hang this through the through on your retort stand, right? Like this. This is your retort stand, right? And this is your this will be your thread, right? Which is basically over here, right? Imagine this gate is straight, right? So you will basically do this. You will hang the lamina, and in front of your lamina, you will hang the string with the ball bearing, right? So this would be straight, right? I'm just making it inclined so that just to make you watch कि आपकी line कैसे बनेगी, right? So then you will do what? You will hang the lamina. You will hang the lamina on the retort stand. On the retort stand and place the string. Place the thread with ball bearing at the top of lamina, at the front of lamina, right? Right? So you will have this setup, okay, which you can see over here right now. So you will then do what? You will take a pencil, okay? You will take a pencil and mark a line over here, right? You mark a line over here. Okay, this is the line which is basically when it gets settled out, okay, when your lamina is now rotating around the pivot, and when your thread is also stationary, when it is in equilibrium, you will take a pencil and you will draw the line on the thread with the thread, right, on the lamina. So your lamina would look like this, okay? Your lamina is this. Let me just replicate the lamina, right? So this is your point A, this is your point B, and this is your point C, right? You have hanged the lamina through this hole, and you have got this particular line with a pencil, right, on your lamina, right? And then you will do what? The third step is to basically repeat step 2 for hole B and hole C, right? So you will obtain 3 lines on the lamina, and you will see such lines, right? Okay. And then the last step is that the intersecting point of these 3 lines will be called what? Center of gravity over here, right? Which is also center of mass, right? So if I just write down the fourth step, the intersecting point of all the 3 lines is called the center of mass as well as center of gravity. Does the experiment make sense? Right? So you figure out here roughly around here, all of the mass of the lamina is concentrated. Similarly, at the center of mass, you would have a vector which is basically showing your gravity vector over here, because the weight is also acting at this particular point, center of gravity. Does that make sense? If it makes sense, give me a thumbs up. We can do one thing also. Just let me know first of all, okay, what is the feedback. It makes sense to Varda, Maeve. What about Mashal, Hamza, and Ryan? Does it make sense? Hello, am I audible, guys?
What do you observe? We observe that there is only one point on which the cardboard can be balanced. This point where the cardboard can be balanced is called the center of gravity of the cardboard. Thus, the center of gravity is the point through which the resultant of the weight of all the particles of the body acts. Let us now determine the center of gravity of an irregularly shaped lamina using a plumb line. Make 3 holes near the edge of the lamina so that the lamina can swing freely when pivoted from each hole. Suspend the lamina from the point P as shown here. Hang a plumb line from the point P.
So plumb line is basically string a thread with the weight, right? So we are using a thread with a ball bearing, right? Just to basically make it stable.
And mark the plumbing line P dash on the lamina. Repeat the experiment by suspending the lamina from Q and mark the plumbing line Q dash. Now follow the same procedure for the point R. We observe that all the three lines PP dash, QQ dash and RR dash intersect at one point. This point where all the three lines meet gives the center of gravity of the lamina. Generally, the center of gravity of geometrically shaped objects lie at the geometric center of the object. View the center of gravity of the objects listed here by clicking on the objects.
Right, you can see here for regular shape objects, it is the center of geometry also. Okay, and it is also center of mass, right? Explain. Let me add the link over here. Okay, so I have added this link over here. So yeah, so this there are similar steps, but I use a plumb, not a plumb line. I use a string in a ball bearing just to make it simpler for you guys. So you have the same steps over here that make hole at the edges of your lamina. Okay, and you just hang the lamina from your one of the load, and in front of your lamina you just place your plumb line, and when it is stationary you mark a line it with a pencil, and then you repeat this step with your hole B and C. So the lines where you basically see the three lines are intersecting, that is your center of gravity, right? And for a human, just the last point to cover, and then we'll continue in the next class, inshallah. The last point is, can you explain, let's say if I have a human being, right? What would be the center of gravity of a normal person? Imagine her. Let's say, imagine this is Hamza. Where is the center of gravity of Hamza, of a normal human being? Yes.
Sir, the legs.
Okay. Legs. Anyone else?
Sir, maybe the stomach?
You are close. Close. What point of stomach?
Like the upper part.
It basically it is a navel point of a human body, right? Where you have the center of mass, and at that point you also have center of gravity, right? So at this point, okay, around the navel point, you have your center of gravity, right? So which is basically this, right? Okay. So now let me just tell you a definition of center of gravity, which we have seen in also. Center of gravity is the point through which all of an object's weight can be considered to act, which we have seen. It is a point where the entire weight of an object of a body appears to act, right? It is same as that. So this experiment is just, I want you guys to do the experiment in your homes, okay? After the class, just stick to one of your wall with your foot perpendicularly straight and your hand basically like this, and try to raise your right or basically left or right leg in this direction, right? You will be basically be unstable and you will fall down, right? Because imagine this, until and unless this is the region, right? This is the area of your foot, right? If your arrow W is within this boundary, your body is stable, right? You won't topple down. If you try to stand on your one leg, okay, let's say if you are trying to stand on your one leg like this, right? So your weight component is pretty close to your boundary, right? It is over here. So that is why you start to topple down and you basically are about to fall down. Let's say if you're toppling, if you're trying to stand on your one feet and your feet is way too basically slanted, okay, your body is like this. And if your component of your weight, let me just draw it more tilted. Let's say Hamza is doing an experiment for the law of physics, and he basically does this, right? So now your weight is basically acting like this, right? So at this point, Hamza would वो ठीक है Hamza would fell down, right? So this is basically explaining the idea of stability. So now from this steps, step number one, step number two, step number three, what do you guys get? What phenomena are we discussing over here? We have seen center of gravity, right? We have seen experiments to find center of gravity of regular and irregular shapes. जो हमने अभी डिस्कस किया है स्टेप्स 1, 2 and 3, basically trying to reach a point where you topple down or fell down. So what is this phenomenon called?
Being stable, like
Stability. That's good. So yeah, stability, as we did example over here, right? Okay, Hamza was playing with himself, right? He's trying to basically stand on one of his leg. Okay, let's say he was trying to show off to a little cousin, right? Okay, yeah, look at me, I can stand on one feet without falling. And he basically failed, right? So at the third step, he fell down because I guess he might have not studied this chapter with me before, right? He is now studying it, right? Now he can basically follow all the steps, right? Okay. So now, stability, let me just first of all quickly read the formality stuff over here. The position of center of gravity of an object affects whether it is stable or not when it is tilted, right? So this is an important in the design of such things as tall vehicles, which tend to overturn when rounding a corner, racing cars, reading lamps, even drinking glasses, right? Everything which basically is designed by a mechanical engineer in the physical world, in this earth, right? He takes care of stability, right? Because imagine a bus, right? Imagine a bus. Let's say these are the wheels of the bus, right? And again, these are the windows, okay? And this is the tailpipe. Okay, and these are smoke coming out of the bus. Okay, and imagine if the bus is basically taking a turn, right? And the road is basically tilted, right? Like this. It is tilted at a particular angle of 45 degrees, right? Let's say, and if it is not stable enough, okay, let's say the bus comes over here. The bus comes over here, right? And it is not stable enough, okay? It will basically topple down, right? We'll show it using a 3D picture, right? Okay, imagine we just basically need stability so that the car does not topple over, right? Okay, what does topple means here? It does not, let's say this is a car from the top, from the back side, okay, and this is the wheel one, this is the wheel two, right? This is from the back side, right? So I'm viewing the car from here, right? So what I mean is this, okay, if it is taking a turn, okay, if it is not stable enough, this would topple down, okay, like this, if it is not stable, right? So now this is an experiment over here which I want you to see and analyze, okay? So can anyone explain is it going to fall down in picture A or picture B? The object is going to fall down at position at scenario A or at scenario B.
In scenario A, the object will fall down.
Okay, so because this, let's say we had a case before this also. Let's say case C. Okay, if I extend this further, so imagine this was standing straight, right? Let me just choose the same color. Imagine it was standing straight, right? And let me choose this option into shape. Okay, imagine it was standing straight, right? Oh my God, that's a good rectangle. Use this tool further, right? Yeah. Okay. So this is scenario C when it was just stationary, right? And we were not playing with this object. Okay. So it is stationary and it is pretty much stable, right? So now again, for the love of physics, I'm doing experiments, right? I'm doing experiments with it to just basically check its stability, right? So what is stability? So basically we try to topple the object by certain angles, theta, right? And we find what is the angle after which it basically topples down, right? So over here, theta is 0 because it is not inclined right now. Let me just turn off this option of creating shapes. Okay, delete it then. So I want to basically just this is theta zero, right? Which is not toppling right now. So I begin to apply a force in this direction, right? Now at scenario B, I have it at this particular scenario, right? So this is the center of mass over here, and the center of gravity is also passing through this. That is vertically downward, right? Okay. So this is basically, let's say, A, B, right? So I want this W to be between A and B, right? So this is point A, B. Okay, this is point A, B, right? So at picture B, at scenario B, again my center of gravity, okay, is basically between A and B. So if I again apply a force till here and again leave it, so it will come back to its original shape. That is basically scenario C, right? Now at scenario A, what is happening? My W, my center of gravity is basically getting out of my A and B, right? So now this would not regain its original shape, right? So now this will basically, if I basically if I leave it, okay, so it will basically topple down, okay. So what is stability? So can you define stability now from this explanation? Can you explain stability now from what we have seen right now? Yes. Anyone? Okay, no one. So it is the ability of an object to regain its original position, right? Does that make sense? So if I keep on disturbing this particular object, and if the center of gravity remains between A and B, so it will regain its original position, right? Which was this, okay? But if it goes out of the boundaries A and B, it would topple down, right? So stability is defined as what? It is the ability of an object to regain its original position or maintain its original position after disturbance, right? Okay. So this is what is defined over here. An object topples or falls over when the vertical line, that is the center of gravity, it's basically falling outside its base, right? So you can see that this goes outside the base and it basically falls down, right? It fell down. And otherwise it remains stable, right? Till until and unless this vector, that is vector center of gravity, that is W, that is passing through the center of gravity, is remaining between A and B, is going to basically again remain stable. Otherwise, it would basically lose its stability, right? Okay, so stability के लिए we need two conditions, right? We can increase stability of an object by two things. ठीक है? So let me just do an experiment with you guys for that. Imagine we have glasses, right? Imagine you're doing an experiment on a let's say on a table, right? And for a table, I need brown color. Where is brown? Where is brown? Brown is here. Imagine this is a table over here, right? And you have two types of glasses. You have glass A and you have glass B. So if I ask a question from you guys, this is glass A, this is glass B. Question is, which glass is more stable?
Class A.
Okay. So those who says glass A is more stable, raise your hand. Okay, Ruba says it, Hamza says it, Mashal says it. Otherwise, Ryan and Varda and May are saying, sir, glass B is more stable. Okay, so okay, Varda is now switched her pole. Ryan, why is glass B more stable?
Because sir, its center of gravity is lower.
Okay, is it lower?
So you can identify why the answer A is correct.
So, Ruba,
Because
because the glass A has a wider base area and stability depends upon the base area. So glass A has a wider base area, so it will be more stable, whereas glass B has a smaller base area. That's why it's going to be less stable as compared to glass A.
Okay, good. Yeah. So everything comes for to the point of center of gravity, right? So center of gravity can be affected. Yes, Hamza? Any question? Okay. So center everything comes to basically center of gravity, right? So center of gravity is affected by two things. It is affected by either its base area, ठीक है, as you can see over here, and it should basically depend upon base area or center of gravity, right? Let me just flip it out. The stability over here. The stability is basically dependent upon two things: the base area and the position of center of gravity. Okay. So यहाँ पे we can decide using the idea of base area, right? As you all did, this is the base area of A and this is the base area of class B, right? So you can just see this, right? This is area of A and this is area of class B. Okay. Hello, Ryan. How are you? I can see you. Okay. So as Ruba said, sir, area of A is basically greater than base area of basically, let me just write completely that you're not confused when you're reading the notes. Therefore, A is more stable, right? Okay. अब मुझे बताएं कि what about center of gravity? Can you locate center of gravity at glass A and glass B? Roughly, कहाँ पे होगी? Where would be the center of gravity of glass A? Roughly, it would be basically be around here, right? If it is symmetrical, a cylinder, it would be basically be here, right? But for glass B, it would be roughly around here, right? Because most of the mass of the glass B is at the top, right? So it would have a center of gravity which is greater than, basically higher than the glass of A, right? So the lower the center of gravity, the more stable it is, right? So you can also compare it from center of gravity point of view, right? So you can say that center of gravity point of glass A is lower than the center of gravity of glass B. Therefore, it is basically A is more stable than. And you can do it experimentally, right? If you have these two sort of glasses in your homes, you can try to basically topple them and topple them by a force. And you can note after what point they are falling down, right? So we would see that glass A can basically remain stable after a great change of angle, right? However, glass B would fell down before glass A basically falls down, right? So therefore, A is more stable. These are all practical stuff which you can do at your homes, right? So does this make sense? If yes, then give me a thumbs up. It makes sense. So Ruba, Ryan, May, everyone. But so again, for increasing stability, it comes in your MCQs and your theory. You can just lower the center of gravity, or you can increase the area of its base height. Either way would increase the stability, right? Okay, so now this is on this particular diagram, you can see this there is basically a truck, fire truck, right? There is a fire truck over here, okay, and they are basically lifting it by a particular angle, okay, that is theta, and they're checking basically trying to find its basically its stability point, okay, after which angle it topples down, and also its center of gravity, right? So if they can find, this is an experiment which you can read further in your book. So there is much this is not so much important. Just imagine that they're trying to topple it down and they're trying to find the particular angle after which it basically fell down, right? So similarly, the coaches, the buses, every vehicle which is designed, they are basically checked for its stability, right? Because they move around roads which are tilted, right? They move around hills, they move around mountainous regions which have roads which are tilted, right? So they and for basically for passengers, for basically simulating that they are passengers inside the coach, they have put bags of sand, right? Just to assume that there are people inside this coach, and they're tilting it by a particular angle, which you can see. This is the angle by which it is being tilted, right? So they're trying to find its stability. Okay, let's say designer said okay, the angle at which it can regain its stability is let's say 24 degrees. So it can go over roads which are basically like this, right? Which have an deviation of tiltation of 24 degrees, this bus would not topple down. Otherwise, if it exceeds 24 degrees, it would basically topple down and it would basically cause an accident, right? That is why they're pretty rigorously checked before basically it is uh, purchased by the manufacturer by the consumers. Okay.
Yes.
Okay, good. So just last ending points for the chapter, then we move towards doing question answers, right? This is basically an application of stability, right? Okay, how can you basically alter stability to make objects stable, right? And they are playing with the idea of stability to create toys also, right? So have anyone played with this toy? किसी ने बनाया ये वाला toy? So basically you have a container. This is a container over here, can, ठीक है? And you take a needle, right? So needle पे you basically put a needle through the cork, ठीक है? A wooden, you can say, cap, right? And then you have two basically forks over here, right? So stick, you basically do what? You put the fork like this, ठीक है? And you put this particular part such that this particular needle becomes stationary, right? So they are basically balancing this particular thin needle on a can using ideal stability, right? So they have added more supporting parts, right? Which basically does what? It balances out this center of gravity point, and this, let's say, this is the center of gravity of the needle and the cork. So it basically passes exactly through the center of this, like this, right? So this is W, which basically makes it stable. Does that make sense? Okay, how are they playing with the stability idea?
Yes.
So they make sure that the W is basically inclined with the needle, right? If it falls out of the needle will fall down. Does that make sense? Yes, if yes, thumbs up.
Yes.
I cannot hear you, Hamza. Can write in the chat. Yeah, does it make sense? So you
Sir,
basically
can you explain this once again?
want okay, ये कहाँ हो गया? कहाँ गया? You basically want this to be done. एक minute, let me zoom out. You want to basically do what? You want to make sure कि for stability, हमने देखा था ना कि अगर let's say if you have a can, right? And this is point A, this is point B. So your center of gravity vector should pass between these two, right? It should stay between these two boundaries, right? Similarly, if I zoom in further to this particular section, I would see it's sort of this, right? If I zoom in further
Yes.
to this point, I will see okay, this is a cross section, right? Which I will see. So I want this W to be small, to be between these two small boundaries, A and B. If I just label over here, this is A, this is B, right? So I want them between these two. So I'm using forks over here to balance it out to find a point such that basically it stays between point A and point B so that it basically becomes stable.
Okay.
Does that make sense? Okay.
Yes.
Okay. So if it makes sense now, give me a thumbs up. Okay, it makes sense to me. Mashal, Varda. Okay, good. So now similarly, you might have seen these toys also, right? You might have these toys, your cousins playing with it, or your little, uh, you can say sisters, brothers playing with these toys, right? So what do they have? If I just explain this parrot over here, this parrot is basically made up of wood, and it has a very long tail, right? So they put a bulldog clip over here. So what happens basically is that, okay, they have lowered down the center of gravity, right? So they basically bring the center of gravity lower. Okay. So this is the center of gravity which basically gets lower after putting this weight on this particular toy. So which basically makes it more stable. And this parrot, let's say this was the center of mass, right? This was the center of mass, and this basically makes sure that this vector passes through the center of gravity, right? So it basically makes sure that it is balanced out, right? Similarly for this toy also over here. Okay. And have has anyone played with this toy, sort of toy, in any party or carnival or any, let's say, any instance in their lifetime? You might have played with this toy. You can punch it, you can kick it. It again basically stands up. Has anyone played with this? If yes, give me let's say, a raise of hands. Ryan has played with it. Maeve also, right? So how do they design it? Okay, so we have also Varda with Hamza also. Okay, so how do they design it is as follows. They basically, the base, right? The base of this toy is pretty heavy, right? So if you try to punch at the base, your thumb's toe would basically crush out, right? Because it's usually pretty heavy, right? It's usually made up of heavy rubber. So the most of the mass of the toy is at the bottom, right? So it is pretty mass dense, right? So what happens, and this is basically made up of plastic. It is basically used of plastic, and it contains air inside it, right? So if you kick it or if you punch it, okay, it goes over here. Since this is curved, right, it makes sure it comes back again, right? So this curved path, which is heavily dense with the mass, basically has lowered the center of gravity to this point, right? Which made sure it would not fall down, right? So this is the sort of center of gravity, and this is point A and this is point B, right? So it always stays between these points, therefore it is able to regain its original position, right? Does that make sense? If yes, thumbs up. Okay, it makes sense to Ruba. It makes sense to Ryan. What about others? Hurry up, then we'll start with the question answers. Okay. What about others? Mashal, Ryan, and Varda. Okay, so okay, it makes sense. Okay. So this ends up your chapter.